We're going to spend the next 3.5 hours building a full-stack modern React app using my favorite web tech. In the back end, we're obviously going to be using Bun and the Hono framework, which works with all JavaScript runtimes. So I use this in my serverless environments as well as on my Bun servers. The front end is going to be a Vite React app, which will be all client-side rendered, no server-side rendering or React server components. And all of this will work with React 18 or 19, whichever one you want to use. Tailwind for styles and all of the Tanstack libraries for querying, routing, and forms. The front end is going to make HTTP requests to the back end using Hono RPC, so we get TypeScript safety there. The front end and the back end are both going to use Zod for validation. We're going to be using Kinde Auth as the fully managed auth service for this. And I've been using Kinde for a while. It is my favorite auth service, and they were nice enough to sponsor this video, so thank you, Kinde. And we're going to be setting up authorized routes on the front end and the back end, so only logged in users can perform certain tasks. The database is going to be a relational database, and it doesn't really matter which SQL database you use for this, but I am going to be using Neon Postgres because it's what people voted for, and we're going to use Drizzle ORM, which is the best way to interact with a relational database from a TypeScript app. Then towards the end of the video, I'm going to show you a little bit more advanced stuff with front-end caching and optimistic updates that makes the front-end client-side rendered application feel really nice and native. And of course, we're going to host this thing. So in development, we're going to be using Vite Proxy to proxy requests to the backend so that in production, we can deploy this whole thing to a server. And I'm going to be using Fly.io to deploy this stuff, just because it's really easy to deploy there, but really you could deploy this to any virtual private server. And all of this drawing was done on eraser.io, and I'll use this a few times in the video to explain certain concepts here and there. And they were also nice enough to be a sponsor on this video. All this tech is really awesome. I love working with all of these things, and to make sure we really focus on the programming and on the tech, we're going to keep the application fairly simple. So we're going to be building a basic expense tracker app where you can see expenses, you can create new expenses, you can delete them, you get little UI updates. It's nothing special, but the tech behind it is really awesome. This tutorial is meant to be for any web dev, junior or advanced, that wants to learn how to build a modern React app using this tech stack with Bun and Hono in the back end and React in the front end. But if you're brand new to React, check out my introductory videos on React, and I'll put a link to those in the description. We're going to be using Bun as the JavaScript runtime, which is basically the alternative to Node here. So I'm going to install this by going to their homepage and copying this straight into my terminal, and this will install Bun for us. Then I'm going to create a new directory for this application, and in here we're going to set up a new Bun server. So I can actually do that by running bun init, and I think I'm just going to stick to the defaults here, and then I can open this up in VS Code. And this is just going to be a default Bun project right now. We'll have a tsconfig, a readme, a package.json, and this index.ts file, which is going to be the entry point of the application. So I can run this file just by running bun index.ts, and it's going to give me that console log. But really what I want to do is bun watch the index.ts so that we can make changes and it will just update that for us instantly. So I could just change this and that just updates for us straight away. And what I'll probably do here is immediately create two scripts. We'll have the start script, which will be bun index.ts, and the dev script, which is going to watch for those changes and restart every single time. So bun watch index.ts, and that should be scripts, and I need a comma here. So now that allows me to just run this with bun dev, and that'll start the server. But it's not actually a server just yet. I think there's a section right here somewhere, yeah, on setting up an HTTP server. So to set up a server in Bun is super easy. This is all the code you need. I just want to steal one that has a port number 2. So I'm going to go into index.ts. I'm just going to dump this code in. We're going to run on process.env.port or 3000. And actually, as I'm typing this out, I can see this comment here that says, by default, Bun will just do that for me anyway. It will either choose the port environment variable or port 3000. So that's a pretty cool default I didn't actually know about. So I can just delete that. It's going to run on port 3000. I'm not going to have a host name in here. Although if you're running this from a VM, like if you're running it on Windows through WSL, it can be helpful to manually specify that you want this to be the host name to bind to, but I'm going to leave that out. So this is a Bun server. This is all I need. I'm going to respond just with hello from Bun server here. And I'm going to change this console log just to say server running. So I can see the server is running here. If I go into my browser and just go to localhost 3000, I can see hello from my Bun server. And that function that I have in the index.ts, this fetch function, this is going to handle every single HTTP request to this server. So it doesn't matter what endpoint I go to, it is always going to be served up by that function. So obviously I could write a bunch of if statements in here to check what kind of request we're getting, what the method is, what the URL is. But instead, we're going to use a really nice server called Hono. And this is going to make it much nicer and much more familiar. So I'm going to take this default code here and I'm going to go back into the app and set up an app.ts file and just paste that code in here. And it needs Hono, so we can bun install Hono here, bun dev. And then back in here, we're exporting app. Okay, so I'm going to delete these comments. So in my index file, what I need to do is import app from app. And then instead of implementing a custom fetch function here, we're going to use the built-in Hono app.fetch function. So all HTTP requests are now going to be handled by the Hono library. So in here, we can set up our endpoints in that really familiar way where I can go app.get. So we're going to accept one maybe at the root route or maybe a test route. This gives us a context object when we pass it a callback function. And I'm just going to write a response here to get rid of those warnings. So c.json message test. And this context object that we get passed in here is going to be responsible for handling the HTTP request and response. So we can get the request data from this object, but also respond with things like JSON or HTML or whatever we want. We're just going to respond with that and make sure it's working right now. So if I go to /test, we can see that custom message. And if I go to a route that I haven't defined, we get the Hono 404 message. And if we go back into the docs and check the context section, we can see all of the things that this is capable of doing. So we can grab headers, we can set status codes, basically all the stuff that you would expect to have in an HTTP library. And we can also really easily add middleware in this library. So I'm going to come to middleware and I'm just going to look for a logger middleware right here because this is pretty standard. This is going to be app.use? Yeah, app.use logger. I'm just going to copy this so I don't get it wrong. Now we're going to have some logging middleware in here. So if I go back and I make a new request, let's go to the test endpoint. We're now going to be able to see that in the logs, the request coming in and the response going out. It's just a little bit nicer when we're trying to debug the HTTP requests. This is going to be an expense tracker app. So we're going to need routes to get expenses, create a new expense, all the CRUD operations. So I'm going to put this in a new file and I'm actually going to make a new folder here. I'm going to call this route and I'll put expenses.ts in here. So we're going to import Hono from Hono. And then to create a new route is exactly the same as creating a new Hono app. We just create new Hono. So I'm going to call this something different. I think I'm going to call this expenses route and we're going to export this from here. And then we can just add all the get and post requests to this. And we can do this individually, but it's going to be a little bit more helpful later on if we just chain these all together. So I'm going to have a get request, which is going to respond with all of the expenses. So I'm going to have it be a JavaScript object like this. So we'll see.json this. So this endpoint will return an object with the key expenses and then an array of the expenses that we get from the database. I'm just going to stub all of these in right now. So if I make a post request to that same endpoint, this is going to create a brand new expense. And I'll just fill this in with an empty object for now. And we'll also add in the standard ones to delete and put, but I'm going to add these in a little bit later. Let's just focus on the get and post for now. So I'm exporting this route. I'm going to define all the expense routes in this file. And then in my app.ts, I'm going to import this route. So import expense route from routes expenses. I'm going to have my app serve that up over route/API/expenses and then pass in that router there. If I go to /API/expenses, I'm going to expect this endpoint or this endpoint to be the one that handles the request depending on if it's a GET or a POST request. So if I go into the browser and make a GET request to that endpoint, I would expect to see expenses empty array. Let's just test that's working. And there's my empty array. And then if I made a POST request to that endpoint, it would be handled by this post right here. And obviously this is going to be getting and inserting data into a database. But before I get that far, I'm just going to create a fake database, a fake expenses array. And this is going to have all the properties of an expense. So let's make a type for that. Type expense is going to have an ID, which will be a number, a title, which will be a string, an amount, which can be a number for now. I'm going to make this an array of expenses, and then I'm going to ask Copilot to make some expenses for me. If I am making the GET request, I'm going to serve up that array of fake expenses. And then if I'm making a POST request, I need to insert a new expense into this fake database array. So the way we get data in the POST request is through c.res.json. And this is going to give us any JSON data that was posted to this endpoint. And obviously I'm going to need these to be async. So what I'm expecting is for someone to post a new expense object to this endpoint. And then right now I'll just send this back down in the response. And I'm going to console log this for now, just so we can see what's going on. And I'm just going to test this POST request out quickly using Thunder Client. So I'm going to make a new POST request to localhost 3000/API/expenses. And the body here is going to be JSON. I need to input, well, I don't want to put in an ID because that's going to be generated by the database, but I'm going to put in a title, some expense, and an amount, which is going to be some number. And then if I hit send here, I'm going to expect this not to give me a 500 error. Let's see what happened. This is not going to be res, obviously it's going to be rec. Okay, that was a stupid mistake. Let's try that one again and hit send. Okay, so I'm sending this data. It seems to be working because it's giving me the response back. I can see that it's console logging out expense here, some expense, 1, 2, 3, 4. But there's a few things wrong with what's going on. So right now, if I hover over this, I can see expense is any type. And even when I had that messed up, I think it was still just giving me, oh, it's unknown type. So I need a way of checking that the data that is coming over the POST request is actually what I expect it to be. In this case, a valid expense object. And I only want this code to run if someone has posted a valid expense type. And the way we're going to validate this data is to use the Zod library, which is pretty much a standard tool for any TypeScript developer now. It is a TypeScript first schema validation library, and there's a lot of documentation here, but I'm just going to use some of the basic things. First thing I'm going to do is install Zod. So bun install Zod. And then in my project, I'm going to bring in the Zod library. And before I use this, I actually want to talk a little bit about why we need a validation library, because we have TypeScript. So I could say that the response coming in has a certain structure. I could say that the user is definitely going to post an expense object, and now in my TypeScript code, I get to use this as an expense object. So I could try and access certain things that I know only an expense has, so we could try and grab the amount property from it, and my code isn't going to give me a warning because I've told it it's an expense object. But this is only a compile time check, and you can see it's really easy to just tell the compiler whatever I want to tell it. So it doesn't really matter what the user posts here. I could post whatever I want. I could add some random properties, or I could misspell things, whatever. It doesn't matter. If I send this, my code will still compile. I'll still get the sense that this is working correctly and that I have safety, but nothing in the JavaScript runtime is going to check if this is actually the correct data being posted. So with Zod, we can create a new validation object. So I'm going to create a new create post schema. And this is going to represent the structure of the data that I want when someone tries to post an expense. So I'll make this with z.auth object and then provide the properties that I expect this to have. So when an expense is posted, I really just need it to have a title and an amount. And I'm going to say title has to be a string and amount has to be a number. And then I can use this to validate my data. So let's say this is the data coming over the post request. And in order for this to be an expense, it has to pass that schema validation. So I'm going to pass this object into create post schema only if this meets those requirements. It has a title and amount and they are those types. Then I'll get this expense object with the TypeScript type that I expect it to be. And if it doesn't, then it will throw an error in this case. So now if I make that request and I have incorrect data, I would expect a internal server error to happen. But if my data is structured correctly, then I get a 200 OK. So this is going to be a runtime check to make sure my data is structured correctly. And I can go even further here. I can say that this string must have a minimum length of 3 characters and a maximum length of maybe 100 characters. I can say the number has to be an integer and that it has to be a positive integer. So I get this runtime validation of my data that also gives me the correct TypeScript types when that validation passes. But since doing this at the HTTP layer is such a common thing, we're going to use a built-in function from Hono. So if we go to the validation section, it has a Zod Validator, Bun and Hono Zod Validator. So I'll add that in here and then we can bring that into the application. So I'm going to go to the top of the route and I'm going to bring in the validator. And then for every route that we want to have this Zod Validator, we just use the Z Validator function. For my post request, I want to make sure that the data that comes in already has that structure. So I'm going to pass this in as a middleware function. I'm going to say that this is going to be JSON data and that it has to meet this requirement right here. This will get run before my route function even happens, so I know the data is correct before this even happens. And then instead of using c.rec.json, I'm going to use c.rec.valid JSON, and this is going to contain anything that was validated before this ran. Now I should be able to see data has that schema with title and an amount. And then I'm just going to add this into the fake database. So fake expenses.push destructure this and give it an ID. Now this should push that into my fake database, so I should be able to create and get these expenses. Let's post a new one. If I change this to a GET request, we should see all 3 expenses that exist, or 4 I guess. And I did that wrong. It's supposed to be length +1, not that it matters that much. Now I'm going to continue adding some more endpoints here. So one of the other ones I might want to have is if I go to /ID, I'm going to get a specific expense object out of the database. ID is going to be a dynamic path parameter. So I'm going to go over to routing and you can see this is how you create those dynamic path parameters. I'm just going to copy this bit of code. You can see there's different ways of doing this here. And I'm going to put that in here. So we're expecting an ID to be passed in. So first thing I want to note is that ID has type string because any path parameter is gonna be a string by default. So we need to convert this to a number, which I can do with number.parseInt, because I actually do want to pass it into an integer since my IDs are always going to be integers. But there's nothing stopping me from passing in just any random string. I could go /API/expenses/SAM, for example, if I just wanted to. So I need to first make sure that this is an integer before I try converting it to that integer type. So here in the routing section, I'm going to scroll down because we can pass in regular expressions. This is a really common thing to do in the path params. And this one should be exactly what we want actually. So I'm going to say ID has to be a number. It has to be one or more numbers. So this is going to make sure that it's definitely a number in order for this route to get run. So if we don't pass in a number here, a route just doesn't exist for that. If I went /SAM, it just wouldn't go anywhere. It'd be a 404 not found. So now I know that this is definitely going to be a number. I can check the fake database. So let's say fake expenses find expense where the expense ID equals the passed in ID. If the expense doesn't exist 404. Otherwise, we'll return c.json, and I'm going to pass that expense back in an object. So the key is expense. The value is going to be the value of that object. It's giving me a warning. It's actually messed up here. We don't return statuses, and actually there's a built-in not found function that I can return here if we haven't found an expense. So this should just be able to get me an expense. Let's test it out and see if it works. /expenses/Sam should just give me a 404 not found. /1 should get me the first one. 2 should get me the second one. 20 should get me a not found. Okay, so that route is now working. So we can do something similar to be able to delete an expense. So I'm going to put this delete in here, and it's going to be very similar. So I'm going to copy all of this. Again, we only want a number. If we can't find the expense, we'll give a not found. However, if we do find that expense, let's delete the expense from the array. And I'm only a little bit embarrassed that I've forgotten how to splice, and I need Copilot to do this for me. So that looks good for deleting, and I think I'll just leave put alone for now. Updates are kind of version 2.0 features anyway. As long as you can get, post, and get a single item, even deletes are nice to have really. But this all seems to be pretty full. It seems to be exactly what I want right now, except post should give me a status of 201. And up here, I'm actually going to improve this Zod stuff just a little bit because I've got a tiny bit of duplicate code here. I'm creating this type, but really this type kind of exists as the Zod validation object. So instead, I'm going to create a new Zod object. So this is going to be expense schema. This is going to be the object as it exists in the fake database. And I'll create a Zod object for that. This will be good because I'm going to end up using these concepts when we set up a real database later anyway. So the expense schema is going to have all of this plus an ID that is going to have to be a number that is an int and is positive, maybe with a minimum value of 1. And then my create post schema is going to be the expense schema, except I don't care if someone passes in an ID or not, so I'll just omit the ID. This create post schema is still the same as it was before, but I can infer the type of an expense from this schema here. So I'll define the type really using Zod and all of these Zod functions. And then when I want an actual TypeScript type here, expense, I can say this is z.infer type of expense schema, and this will now give me the expense as a TypeScript type from this Zod object. So this is the source of truth for the schema of my logic here. And this doesn't matter too much for a fake database, but we are going to keep all of this in mind when we get to a real database later on. So now what I want to do is set up a React front end so that we can actually connect to these API endpoints and get some communication between a front end application and the Hono server. So what I'm going to do is first I'm actually going to organize this code a little bit because I'm going to put my front end code within the same directory here to make it easier to share the TypeScript code between the backend and the front end. And some projects might go far enough to create an actual mono repo for this, but I think just dumping the front end project into this project as it is more than sufficient to get this working. So I am going to start by just creating a server folder, and any code that is specific to the server, so that's app.ts, index.ts, and my routes, I'm just going to put in this server folder. So let's put that and these two in the server folder. Everything else should really just be configuration or information files. So that all seems fine. I'll probably have to update the start script. So this is now server/index, server/index, the module is server/index. And then within this project, I am going to create a new front end React application. So I'm going to do this with bun create Vite at latest. I'm going to call this front end. We're going to select React and just TypeScript from the top there. And now I can cd into the front end application, bun install. And before I run bun run dev, there's one more thing I want to do. If we go over to the bun homepage over here and I check the guides, I think there is a Vite. Oh, right there. It just has a couple of different scripts that we can use. So instead of just running Vite for the dev script, we're going to run bunx bun Vite, and we're going to do the same. So here's the front end code. Here's the package JSON. So I'm going to update the dev script, and I'm going to update the build script too to be the bun version of that. Bunx bun Vite build, because obviously we want Bun handling the TypeScript stuff instead of TSC here. So that's good. Now I can run bun dev just to make sure this is working. And it's really important that you have the front-end dev server, the Vite server, running at the same time as your backend server. So I can run bun dev on the backend. This is my server running. It's running on port 3000. This is my front-end React app, and it's running on the Vite dev server at 5173. So make sure those two are running at the same time to make sure they can actually communicate with each other. So now if I go back into my application, I can see that I have a front end and a server folder. So this is where all my front end logic goes. The server is where all my back end logic goes, obviously. So in the source directory of front end, I can see I got my app.tsx, my basic React app stuff, right? So I am gonna just make sure that's working. Let's go to localhost 5173. And yeah, I can see this, the basic Vite React app. That's all working, that's fine. Now, before I go any further, I'm going to install Tailwind into this project because I want to use that for styling. And I will go over why I prefer Tailwind to using just CSS or other things, but I'll do that after I've installed this. So we're going to grab this, and instead of npm or npx, we're going to use Bun and bunx because it's a Bun app. So make sure that when you are installing your front-end libraries, you are in the front-end folder, Bun, install, developer dependencies, Tailwind, and we're going to need this line too. And instead of npx, we're going to run bunx. So this will set up Tailwind for us. Then I also need to make sure I've got this content set in the Tailwind config.js. So just paste in their defaults there. That's good. And we need to make sure index.css has these three things. So we'll go to index.css right here in the source directory and delete everything and just put in those three Tailwind things. And then always, for good luck, we're going to restart the front end just to make sure that all works. Before I actually start adding Tailwind, I'm going to explain why I like using Tailwind. So if I go into app.txx, I'm going to delete a bunch of this code. So I'm going to get rid of this top stuff here. I'm going to get rid of this stuff at the bottom, and I'm going to leave this part in here that has the button that you click to make the counter go up and down. But I just want to leave this part in and change it a little bit. So we're going to have the count in a p tag, and I'm going to say this button is up and this button is down, and this is going to reduce the count by 1. And I can delete this heading here too. So now this looks like this. It's still functional. It doesn't really look that nice. Now I want to style this, and the first thing I don't like is that my styles are in a separate location than my actual markup, because my styles are very closely coupled to my markup. So if I go to my app.css here, I can see a whole bunch of styles for things that I just deleted because they are separate. So I now have to make sure I come in here and delete all those things that I deleted in the markup. So it'd be nice if those two things were together. The second thing is, if I want to style the buttons here, that's fine. I can just say I want to style the card buttons. So card button, let's just give this a background color light blue. So that now styles these buttons, and I'm going to make this flex and flex direction column. And that's styled exactly as I want it, so that's fine. Then I go back in here and I decide that I want the down button to actually be light red. All other buttons in a card, they can be blue, but the down button, I want that to be red. So then I have to come up with a class name here, and naming sucks, naming is hard. I just don't want to have to think about it at this step, but fine, I'll add a little class name in here. We'll call this down button. Maybe it's good, maybe it's bad, I don't know. Come into app.css, different file, make a new rule for this. Let's just give it a background color of light coral. And this seems like it should work. I have the class name, I've specified the rule, but if I go to the browser, this isn't going to change the color of the button. And the reason this isn't going to change is because it isn't specific enough. So doing something like this would actually make it change. And sure, understanding CSS specificity isn't super difficult, but it's another thing that I don't want to have to think about when I'm just trying to style a button. I just want it to be red. So one solution to all of these problems that I've identified right now would just be to use inline styles instead. Let's go styles equals, give it an object and say the background color is coral, and that's actually just style. And now that updates that single element. So this would solve all the problems, but everyone knows inline styles are bad, and you may or may not know why they're bad, but everyone knows that inline styles are bad. One I'm going to focus on is that there is no opportunity for pseudo classes. If I want to change this background color when I hover over the button, I cannot do that with inline styles. So in order to get the best of both worlds, where I get everything that I want, I can use a library like Tailwind, where I can say that the background color is, let's go red 100, and the background color of this one can be blue 100, and maybe this is just flex col, and I'm going to remove all of these styles from my app.css. So now I'm going to get that styling. That's kind of what I wanted. But I can also add the pseudo classes. So when I hover over this, I actually want it to be bgred 300. And now that just works. And I don't hate the utility class names that it uses. And there's a lot of other benefits to using something like Tailwind. And it gets even better when we use a good Tailwind component library. So we're going to use shadcn for this, because this is a nice component library. It's very simple, very minimal, but it also has a lot of accessibility features built in, so you don't have to really worry about that. And if you don't want to generate a UI, you can use v0.dev, which is kind of good at building a UI using AI. So we're going to use this. I'm going to go into, let's see, probably docs and installation, and we're going to set this up to work with the Vite application. So we've already got Vite set up. We've already installed Tailwind. It does actually suggest setting up a few other things, which are super nice, like having this path here. So I'm going to follow these instructions. We're going to edit the tsconfig JSON file in the Vite application. So let's go to tsconfig, make sure you're in the front end tsconfig. In the compiler options, we're just going to add this in. So the base path is the current path. And then we're going to specify that we can include any module in the source directory of the front end by using @/, which is kind of nice. I do like that. So we're also going to have to update the Vite config right here to resolve that alias. So I'll put that into the Vite config, wherever that is, right here. So just right there, that looks good. But we're going to need to import path from path. And I think this wants to be meta.import.meta. All right, cool. Then we're going to actually set up shadcn. So we're going to run this with bunx from the front end directory. So over here, bunx shadcn-ui latest init. And we're going to go through a couple of options here because it is going to modify the application a little bit. So yes, we're going to use TypeScript, just use the default. I quite like neutral, but you can pick a theme. So if you go into shadcn, let's just look at the home page, maybe, no, themes. You can see some of the default themes it has, and you can customize these if you want. I'm just going to use the neutral theme. So let's select that. Where is the global CSS file? Source/index.css. Source/index.css. Do you want to use CSS variables for colors? That's optional. I'm going to say yes. I like that. Are you using a custom Tailwind prefix? Nope. Where is your Tailwind config.js located? That is just Tailwind config.js. And we'll put all the shadcn components in @/components. Utils can go there. Are we using server components? Definitely not. Right configuration? Yes. Okay. So this will set up the project to use shadcn, which does a few custom things. So if we go to the Tailwind config, it did a lot of customizations here for the theme. These are all cool things. You can change them if you need to, but we're just going to leave all the default settings. I am just going to add in the index.html page because I want any styles I put in that page to also be picked up by Tailwind. And if we look at the index.css file, it has created a lot of variables for the default theming. And this is cool because it allows us to add more consistent styles to everything. For example, if I go to app.tsx and I wanted to make sure this button's text color was the default theme's text color, I can just go text foreground, and that is the theme's foreground color, and I could make this entire card here BG background. So it's just the default background color, the default foreground color, doesn't really matter what they are, that's just going to be those colors. So the foreground color is just black and the background is just going to be white there. But this will also pick up if we change things to dark mode. And we can do that by toggling the dark class on any of the elements. I'm just going to cheat right now, and I'm going to go to the index.html file, and I am going to set class here for everything to be dark. So this is just going to be dark mode. We're not going to be able to toggle it. We could change that later, but I would just rather have everything in dark mode right now. And I think I probably need to restart Vite to get all that working. And And then I should probably use some more default colors. So for the background of buttons, for example, I might want to choose BG. Actually, we could see what kind of options we have in the index.css. So we have a default card color, default popover color, primary, secondary. Let's see, maybe secondary, or I could choose any color really. And in fact, for a button, we would end up just using the shadcn-ui component. So they have a button component, for example. If I want to include that in my project, I can just copy this for bun, and I'm going to come over here and paste that in. So we don't install the actual library, we just add components as we need them. So this is going to add a button component into the project in source/component/button. I could manually update this if I wanted to. I can delete this whenever I want. It only exists if I need to use it. So I'm going to come back into app here, and I don't need any of these things, but I can import the button from, and now I get that @/ so @ gives me straight into source. Then I can go into components/ui/button, and that's going to give me the button from shadcn. So then I could replace all of these with the default button there, and that's going to give me much nicer defaults for all of this. So I'm going to delete the class. I'm just going to see what this gives me right now, and I have extended this all the way to the edge of the screen, so it doesn't look that great. Maybe I'll make this a little bit nicer. I'll say max width MD. Maybe we could do margin auto, and maybe we'll do a gap Y of 5. And this is what the component's currently looking like, and everything still works. So we're going to use the shadcn components just to make this a little bit easier. And the first thing I actually want to show on this page is the total amount spent in my expenses app. So I'm going to create a little card over here from shadcn. So let's go to the card component, and I just want to have the total show up in something like this. So I'm going to bring in this with bun. We're going to bring in the card component, and I'm going to go over to app.tsx, and we can bring in, actually I'm going to copy maybe some of the code they have here. So we get all the different parts of the card. I think I'm just going to copy some of this so I don't have to type it out all by hand. So we're going to take the card and the header and the content. I'll stop there because I don't need any of the form things. So in this app, we will have, close these out a little bit. The title, I think, is going to be total spent, total amount spent. And in the content here, I'm just going to create a new state variable. Let's see, total spent, set total spent. We'll default this, yeah, sure, to 0. Why not? And throw that in here. And I'm not using the set function just yet. I'm not using some of these things. Let's just get rid of them. So that, though, should display the total spent. Let's center this a little bit. So margin auto, and okay. So we got the total spent here on the home page. We'll style this, we'll flesh this out a little bit more. But right now I do want to just display the total amount spent in this bit right here. So for that, I'm going to need to make an HTTP request to my API to get the total spent. And I don't think I actually put that endpoint in the API. So let's go back to the backend. So I'm going to go into the server and routes expenses. And in here somewhere, I'm going to make a new endpoint. So if I make a GET request to /total spent, I would like to send back just the number, the total amount that I've spent in all of my expenses. And in a real database, this is going to be like a select sum of all of the expenses. But for now, I think I'll just get Copilot to get the total from my expenses. I probably should be able to write my own reduce function, but let's see, accept that. Okay, this is exactly what I want. So if I go to get /total spent, it'll give me a total amount. Okay, perfect. So this is the endpoint /API/expenses /total spent. This is the endpoint I need to hit to get that number into this page. So in my app.tsx, I'm going to need to make that fetch request to get that data. And this is going to need to go inside of a use effect so that this happens only when the component first loads. And we will clean this up. We will make this better a little later on, but right now we'll just put this in a use effect. And then we need to make a request to the backend. So this could potentially mean making a request to http:/localhost 3000/API/expenses, but this is only going to work, right? This is the server that exists on localhost. This will only work in development. I have to make sure that this works in development and in production. So So I need to figure out how I'm actually going to host my React app and my server before I start messing around with this, because trying to fetch from my server like this, I mean, first of all, it just won't work. If I go to the browser right now and try and do that in a use effect, I'm just going to get all these cause warnings because I can't just make a request from one origin to another. So we need to fix this issue, but we also need to figure out how the front end is always going to make requests to the back end in development and in production. If you're making a client-side rendered single-page application and you're using Vite, in this case to make a React app, then you get luxuries like being able to write TypeScript and JSX. You get to import node modules straight into your project. You get hot module replacement so that everything updates the moment you make a change, and a bunch of other things, all running on the Vite server at localhost 5173. And this is all part of your development environment. You get all of this in development. But when it's time to deploy your app, you build all of those files into plain old HTML, CSS, and JavaScript files. This is WebDev 101 HTML, CSS, and JavaScript files. And these things you deploy to production. So in development, you need this server running on this port so you get all these special features. But in production, you don't need any server-side logic to serve up these files. You just need to host them somewhere your user can get these static files. So these can be hosted in an S3 bucket or GitHub Pages or wherever you like. But it's really important to remember that these are just going to be static files. Now, in development, you might also have an API server running on a local host port. So in this case, port 3000. And this is going to be where you accept all of the HTTP requests. So this is going to be server-side logic running on localhost that you will have to deploy to a real server at some point. So in production, you are going to have to take all of this code and run it on a real server with a real domain name like myapp.com. Let's say this is HTTPS. And this is going to be the origin of the server in production. And you might decide that you want these files, the front end part of your application, to be hosted on the same origin. And there's a few ways of doing this, but the easiest way of achieving this would be to just put those front end files inside of your API server. So if you make a request to /API /whatever, then you're going to get a JSON response. But if you just make a request to myapp at the root path, then you can get the front end app. So someone in their web browser can just make a request to your server and start using your web app, and then behind the scenes, your front end application is going to make HTTP requests to your API, but it's all going to be at the same origin. Now in development, we have two different servers running. We have the front end Vite server and the back end API server, and these are both on separate origins because we need that for development. But if our plan is to put them on the same server in production, then we want to mimic that in development, and we can do that by proxying requests from the front end to the back end. So we can say that anytime we make a request to the front end Vite server at /API, we want to forward those requests to our back end server running at port 3000. So that way, in development, we'll have our browser and we will make all our requests to localhost 5173, the Vite server. So we can request the front end application from the front end server, and then any API calls that that application makes to port 3000 will do that through port 5173. So in development, everything will go through this single server, through the single Vite server, but then in production, we'll deploy this backend server and everything will go through the backend server instead. And this means that all our requests from our front end can just start with /API since they're on the same origin anyway, and we won't have to deal with cause issues in our local dev environment or in our production environment when we actually deploy the app. And the way we do that is to go into the Vite config, and we're going to add a new option here. So this is going to be server proxy, and then we're going to say that any request that starts with /API we are going to forward to the backend server running on port 3000. So now any request that goes through the Vite frontend server at /API will just get forwarded to the backend server. So this means that anytime I want to test an API endpoint, I'm not going to use localhost 3000 anymore because they can all go through my front end web app. So I could test this out by going to /API/expenses. And even though I'm using my front end Vite server here, it's going to forward that request to the backend server. So it's really important that in development, we always resort to using the 5173 port, the Vite server, and not the 3000 port anymore. We're going to do everything this way in development, and then in production, it's all going to run the other way around. It's all going to go through the backend server, and I'll show you how to set up that part in just a moment. But let's see if we can get this working now. So if we go to localhost 5173, and I actually save this file, we should be able to fetch the expenses here. So let's see, it's not doing anything there, but in the network tab, I can see it is grabbing the total from the backend now. It is effectively getting that from the HTTP request. So now I just need to store this in the total spent so that we can actually see it on the page here. So to do that, I'm going to make a new async function to fetch the total. Then we can await the fetch and get the data as res.json, which also needs to be awaited. And then data should be this JSON object here. So it has a total, and that's going to be the amount. So we're just going to set the total spent to be data.total. And right now this just has any type. We're not handling error or loading states or anything like that. We will make this much better in a little bit. I just want to get this working first. So then as soon as this gets called, we will invoke this function, make that request, and hopefully we should now see that amount there. There we go. So as soon as it makes the request, I think I have, okay, let's stop throttling there. Yeah, so the moment the page loads, it grabs that data, shows it on the homepage. Perfect. So we can now make HTTP requests from the front end to the backend Hono server. Now let's see how we can do the other part of this. So when we're ready to actually deploy this app, and I think we'll deploy it now, and then we can keep updating it as we go through the app. When we want to deploy it, we have to build it, put the files into the production API, and then host that somewhere. First thing is that we have to have a plan for building and actually serving up the React app from the Hono application. And if I check the Hono docs for serving static files in Bun, we'll get right here. So this is what we need. So I think I just need a couple of these. I'm going to copy all of this and then we'll delete some of it. Well, actually we could build this first. So when we're ready to deploy the front end, instead of running bun dev, we're going to run bun run build. And this will build those files into the static assets that I was talking about into the dist folder right here in front end. So right here we have the index.html, I have the index.js, and I have CSS. And it's all been transpiled down and minified. Any unused code gets cut out. It does a whole bunch of advanced things to make sure we get an efficient set of files here. And we can even go further and break these apart even more and download them separately. But for now, this is the simplest version. We have this dist folder. If we serve up the dist folder, then that is the entire front end application. So we need the backend, the server, to just serve up that folder from the front end directory. In app, I'm going to paste this at the bottom, and we're going to need to bring in serve static. So let's see, right? I needed to import that from Hono/Bun, and then I only want the first one and the last one. I can actually make this a GET request, and I'm going to use a star for both of these. And this first one, the root, I am gonna give the path to frontend/dist. So we're serving up the entire dist folder, and we're always gonna fall back to frontend dist index.html. So basically our server is gonna be able to serve up any API route. But if the request doesn't match any of the API routes that exist on the server, we will always just serve up the front end React app in this case. And I guess I really don't need this test route anymore. So if it's going going to an API, handle the API request, everything else, we will go to the front end application. So that means that if we type in a URL / something that doesn't exist, instead of handling that server side, we can still serve up the React app and show a custom 404 page instead of just showing like the Hono 404 message. Anything that's not handled by the API will be handled by the React app, which gives a bit of a nicer user experience. So now I can test this is working before I deploy it by trying to visit the backend API. And the only time I really want to go to localhost 3000 is when I'm testing stuff to deploy it. So I'll go to localhost 3000. I can see the application, the React app seems to be working. If I were to go to an API endpoint, I should get that API. But if I go to any random thing, it should still give me my React app. And we'll have to handle these random paths with a custom 404 page in the React app. It's just nice that the React app is always being served up. So now all I need to do is deploy this Hono server somewhere. And there's tons of different places that you could deploy a Hono server. I have a video that I'll put in the description on how to deploy any Node or Bun app to an EC2 instance. But for this tutorial, I'm going to use Fly.io, just because I found it really easy to deploy to this service, but really you can deploy wherever you want. So if you want to follow along with this, sign up for an account. Currently I'm logged in. I don't have any apps set up yet. So I'm going to go back to the homepage and just follow the instructions for the speedrun launch on Fly.io. And here are the instructions you would need to follow. If this was your first time using Fly.io, you need to sign up and log in. And I'm just going to run fly launch from the root directory of my project. So this is going to be the root directory. Make sure you don't do this from the front end. So fly launch is going to figure out what my application is, set up a Docker file and some other files for my app, and then it's going to help me deploy that to Fly.io. So it's giving me some options here. This is my organization. The app name is app. Region is Seattle. Machine. So I don't really need to tweak any of these settings. I don't need Postgres or Redis. I do want to change the name of the app though. So I'm going to change that. My expense tracker demo, maybe. I'll just confirm those settings. Okay, so it's configured some stuff for my application. If we go back in here, I can see there's a fly.toml file and there's a Docker file. And this is just the set of instructions it is going to use to set up an environment for my application. So you can see it's setting the node environment to production, it's installing dependencies, and it is running the start script that I have set up for the backend. So now all I need to do is run fly deploy, and it is going to deploy it to Fly.io, which could take about a minute to run. That just finished deploying. Here is my URL. Let's go visit and see if my application shows up. It's not working. I have a feeling I know why, but let's just check the logs first. So I think it's fly logs. Yeah, will show me what's going on. It actually doesn't seem to be showing me the logs that I thought it would, but I think the reason it's not running is because on Fly.io, I'm pretty sure we need to say what the port is. So I'm going to go back and I'm going to say this is process.env.port or 3000. And to make logging a little bit better, I'm also going to create a variable for this. And when we say the server is running, we can also print out the port that it is currently running on. And then I'll try deploying that again. I just have a feeling that maybe Fly.io actually does need this port configuration, even though it says it's running on port 3000 and this should default 3000. I just don't trust it. So let's deploy that again. Okay, I honestly have no idea what was going wrong there. Out of nowhere, it just started working. I don't think this was the thing. I even added host name 0000. Nothing seemed to be getting it to work. Then out of nowhere, it started working. So I have no idea what happened there, but it is currently working. It is on Fly.io. This is a URL I can share with everyone. So my application is deployed. That's awesome. And basically every single time I want to deploy an update, I would go through those steps. I would build my front-end application so that my dist folder gets the newest updates. Then I would deploy my backend, and all of this stuff in the doc file would make sure that my backend application with my front-end code gets deployed to Fly.io. But there is something else we can do. So if we go into the Docker file and we modify the code here where it's building up the application, we can add in this block of code right here so that every single time I hit deploy, so fly deploy in this case, it will build the front-end scripts, remove any of the other front-end code within the Docker container so there's not extra code being uploaded, and then deploy all in one go. So if we add a little script to do the build step for us, which I have here, then the build process is just as simple as calling fly build or whatever you're using to deploy your application. You just have to make sure that you build the front end every single time you want to deploy the app. But now that's set up, deploying should be pretty easy. So now we can get back to developing the app. And the next thing I want to focus on is this HTTP request, because right now when we make the request, the data coming back has an any type and we're just making a request to anything. So I could really easily misspell anything in this URL string. And when we get the data back, we actually don't have a strict type on that. So this kind of sucks given that we have the HTTP endpoint over here. We know exactly what it's going to return. We know exactly what the string should be. So when we have a setup like this with TypeScript in the back end and TypeScript in the front end, there's no reason we shouldn't be able to have some sort of type safety with the HTTP requests. And this is where RPC library comes in. And you can use something like tRPC, but any RPC library that works with TypeScript is going to help in a situation like this. And Hono has their own way of using RPC. It's in the guides here, right here, RPC. So in our backend, all we have to do is export the type of the API routes that we have in the backend. So when we export that type, we can then import that into the front end. And since this is just a TypeScript type and it's not a runtime thing, none of the backend logic will actually be executed. We get to just import the TypeScript type for compile time checks. Then on the client side, we can use the Hono client library, and then any HTTP requests we make will actually be calling a function on the client side like this. So we'll know which endpoints we can actually execute, and the response from those will have the proper type on them. So let's implement this to see how it all works. In the server right here, so I have my expense route. What I'm actually going to do is go to the app.ts on the server, and I'm going to refactor this just a little bit. So I'm going to say any routes here that are part of API. So I'm going to set a base path here, /API, and then attach the route to that at /expenses. So anytime I have more API routes that I want to append to this, I'll just add another route. So right now it's route expenses. I could have route categories or anything else I might have in my API. And then I'll store this in a variable called API routes, because anything at the API endpoint I really want to expose to my front end, because those are the endpoints that my front end application needs to be able to make requests to. And then from this file, I can export type API routes, which is going to be type of API routes. And this is just a TypeScript type that contains all information about any of the API endpoints. So now I want to import this into my front end application here. So I could import the API routes type from, and this is going to be in the parent directory, to parents up /server/app. So we're importing that type straight from the server code. And then in the client, I'm going to need the Hono client. We're going to do something like this. And first we need to create a client object. So I will say the client is API routes, and this is going to be / because they're on the same origin. And then down here, instead of making a fetch request, the client is going to make the fetch request for us. So we await client.api, and you can see how it knows which endpoints we actually have access to. So expenses, and then the total spent. And if I misspelt something here, it will complain because it has that TypeScript safety. And then we just need to call .get on that path to actually make a GET request. And then everything else is going to be pretty normal here, except now the data has the type on it. We are safely only going to endpoints that we know exist, and we know the type of the data that's being returned from that endpoint. So this is how we're going to end up using RPC with Hono. Now, there's a couple things I want to clean up here. First, this is going to be shared code. A lot of the different components are going to want to make an API request. So I'm going to take this out and I'm going to put this in an api.ts file in my lib folder. And we are going to export const API equals client.api. So anytime I want to make a request to the API, I can do it like that. And then in my app.tsx, I can import API from @/lib API, and then just call it without the client there. So API expenses. Now it's complaining again because I just moved this to a different directory, which means I need to do another .. But this kind of sucks. This is pretty terrible. So instead of doing it this way, I'm going to add another path to the configuration. So in package.json, in tsconfig.json, I'm going to add another path here. So if I want to go to the server directory, instead of having to go to all the parent directories and then find the server one, I'm going to define an @server path that exists in the parent/server relative to the root of the front end project. And then I need to do the exact same thing in my Vite config. So I'll alias this as @server and paste that in here, but it's going to be /server in the parent directory. And now that means that anytime I need to access any of the server files, instead of having to do that mess, I can just go @server. And I think it can't find this because I probably need to restart my front end application. So that's my back end running. I run bun dev on the front end. That didn't fix it. Let's see. I missed a /star here. That might be it. Yep, there we go. Okay, so now that's pointing to the server directory / the app.ts file right there, so we can import that correctly. And in app.tsx, everything's working. So API /expenses /total spent, make a GET request to that, and the data we get back is this. So that means that I can only access the proper properties on this. If I try to access something else, it would complain. So that's what all of that was for. So we have that safety with the HTTP request, and everything should still be working in the exact same way. I need to go to the local version, but now the total spent is a 500 internal server error because my proxy is not working now because I changed this to bind to 0000. So here's a little trick for you. Localhost will sometimes not work, but 127.0.0.1 will always work. So let's change it to that and everything should be working now. Perfect. Okay, the app still works, nothing has broken, but we now have RPC in there for TypeScript safety. So now I want to fix up this HTTP request a little bit. When we make an HTTP request, we need to handle all the different states it can be in. So it could be successful, we get the data as we expected, but it could also be in a loading state while it's getting the data from the server, but that could fail in some way and we could have an error state. And if we're in React 19, we could potentially replace all this code with a use hook, pass that in, and then just get the data that way. And we could implement an error boundary and a suspense boundary, use, not use effect. But then there's also other things to consider, like caching responses. So maybe we never want to grab the total spent again unless the user creates a new expense. Maybe we want to share this data with other components, so we need some sort of context. We might want the ability to cancel a request to make sure we avoid race conditions. And there's a whole bunch of other things that surround requests for data, but also just async state management in general. So what we're going to do is use Tanstack Query, which used to be called React Query, and this will handle all of those issues and more for us, and it's a really easy library to use. So I'm going to go to the installation. We're going to install this into the front end and make sure you're in the front end directory, and then I'm going to go to quick start, and I think I'm just going to copy a lot of this code and delete it as needed. So in the main.tsx, that's the entry point for our entire React application, we're going to import the Tanstack query things. We're going to create a new query client, and we're going to wrap the entire application in the query client provider. And then I don't actually need these hooks right here. So the main.tsx is going to look like this, where our entire application now has access to this query client, which is named the way it is because it was probably originally just for making HTTP requests, making queries. But this really is a powerful asynchronous state management tool for a bunch of front-end frameworks. And I've used this for managing state between different components and pages, even when no HTTP requests were involved. It is a really cool library. So it's always my go-to for any front-end single page application. So now that we have that set up, we're going to use the simplest thing here, which is use query. Oh, there's an example right here. Okay, so in the app.tsx, I'm going to import, I really just need use query right now from Tanstack React Query. And then I'm going to copy this line of code from the example, and it's gonna look something like this, where we use query, we give it a key. So this is gonna be for getting the total spent from the server, and then we're gonna give it the query function, which is basically gonna be this, but I am gonna wrap it in a different function. So I'm gonna delete all of this, and I'm gonna come up here, and I'm just gonna make a new async function that is get total spent, which is gonna call this. So we'll get the result by awaiting that. Actually, it's going to be just like the code we had in the use effect, and then I'll return the data here. So this is just responsible for making the request, passing the JSON, and then returning the data. And the reason I wanted to put this in a separate function is because fetch by default doesn't throw any errors if the status code isn't 200. So I want to make sure that the response was a 200 status code, and if it wasn't, we will throw a error. Server error is good enough for now. And that just means that this function will either get the response and return the data, or it will throw an error. Those are the only two results of calling this function. So now I'll pass this function to the use query hook, and that's all we need for all of those cases that I talked about earlier. So I can delete all of this code here, and the query returns a whole bunch of things. If you haven't already, you should check out the documentation here. There's a lot that this library can do, but let's come down to examples and just take a look at the simple example, because I think this contains everything we need. We're going to use is pending error, and I don't think you even need is fetching, but we can bring it in anyway. I'm going to copy these pieces of code to then the total spent. It's not going to be that. It's going to be data dot total. You got to love TypeScript for that. So basically, is pending is going to be, is it doing the initial request to get the data? If so, we can return loading. If there was an error, we can return an error has occurred. Otherwise, we have the data, so we'll just display that as normal. And is fetching will be true if it's refetching the data. So if we have stale data, we could show something to the user, but I'll just leave that out for now. And we do have the option to use query, or we could use suspense with React Query. We could use suspense query here and still use suspense boundaries and error boundaries, but we have a lot more options with this Tanstack query library, and we'll use some of those later on. Right now I'm choosing just to put the loading and error states within this component just to keep it a little bit more simple for now. So that should mean that if we go back, everything should still be working as normal. Actually, I'm going to change this one. Instead of just returning when it's pending, let's come in here. Let's say if is pending, then we can just do like a dot dot dot, else will display total amount. And then I just want to simulate it pending. So I'm going to go into the backend here. And when we try to get the total spent, I'm just going to add a fake await here. So I'm going to make this an async function, and we'll await new promise set timeout resolve after I don't know, let's just say 2 seconds. And now if I refresh the page, we should be able to see that loading state, but then after 2 seconds it loads in the normal stuff, so kind of get a glimpse of what's going on there. So that's kind of nice. And if there was an error state, we would see the error page instead. So I'll remove that before I forget to. And now we have in our application a nicer way of using RPC and async state management library to help with all that other stuff, and we don't need use effect or use state anymore. Now I want to add the ability to get all of the expenses and allow the user to create a new expense. But before I do that, I want to add a routing library because I think every single page application needs to be able to handle routes. Every app has some sort of sense of pages or screens or scenes or windows or whatever. And in the browser, when we go to a new page, the URL needs to reflect the new page we're on. So right now I see the total spent, but if I wanted to see a list of expenses or a form where I could create a new expense, those would be different sections, different pages of the application, and the URL should reflect that. That means we keep track of where the user is within the application using the URL. And if they refresh the page, then they still stay on that page. And if a user goes to share a URL with someone, like when people share YouTube links or Twitter post links, that allows the user to enter those applications at a specific place. On top of that, we want to be able to handle which pages a user can see when they're authenticated, when they're logged in. And we might even want to go as far as handling data fetching and page loading states directly from the router. So there's tons of reasons that you probably need a routing library in your SPA. And currently the best routing library I know of is Tanstack Router. So we're going to be using a lot of the Tanstack things in this application. They are all really nice. I love this routing library, mainly because it uses file-based routing, which I've come to really like after using Next for a while. And it's all very type safe, which we'll see in a moment when we get this set up. So first we need to install this library. So I'm going to bun install this into the front end. And then I'm going to go to the quick start and we're going to need to install a Vite plugin here. So I'm going to put that into the front end as well. And this is going to be a dev dependency. And we need to update the Vite configuration because this library will actually create a new file for us and modify some of the route files. We'll see how this works in a moment, but I'm just going to make sure we have this in our plugins. So we have React and we have Tanstack Router Vite. And now we can start implementing some of this code. So I'll just follow through the quick start guide and we'll modify it as we need to. The first thing we're going to do is set up the route in source/routes. So in source, we'll create a routes directory. And in here, I'm going to create __ root.tsx. And this is going to be the entry point into all of the routes we have. So this is kind of like the main layout where we can put the nav bar, and then this outlet thing here is going to load any of the other routes that we have in the routes directory. So every page will have the nav bar, and then they can also have its own custom content for each page. And right now I'm just going to comment out the dev tools. You can install the Tanstack Router dev tools, and that can help with debugging things and seeing what's going on, but we really don't need it right now. So this example has a home page and an about page. So I'm going to copy the code for that too. And this is using lazy routes, but I'm not going to use lazy routes. I'm just going to use normal routes for this. So that was the about.tsx page. So each page is going to be defined in this routes folder. So I have an about page here, and we're going to change lazy file route to just file route. And I don't know if you saw there, but when I saved this file, this is what that plugin is doing. If I put any string in here, if I save it, it's going to make it the correct string. So this is the path, and this is currently needed just for the TypeScript part of this. So it's going to make sure that this is always up to date and always working well with TypeScript. And the other thing the Vite plugin is doing is it's creating this route tree gen.ts file where it defines all of our routes. And this makes sure that we get a little bit of type safety when we create links to our different routes here. So if I go back into the root route, I have a link to go to the about page, and because I have an about page, this is all fine. But if I were to misspell this or try going to a page, this should actually give me a TypeScript error, but it might not be because I haven't got it all set up just yet. So let's finish going through these step by step. So I have an about page. That was actually the index page I copied. That's fine. Let's put in the about page, and I'm going to take the index page and actually make an index.tsx. .tsx here. So this will be the home page, index page, and then I need to replace this with just a normal route instead of a lazy route. So lazy routes will separate out the JavaScript for each of the pages and all of the dependencies in the pages so they all get downloaded separately. It's kind of a cool feature. I just don't want to use that right now. So we have about an index, and that's being managed for me. And then we also need to add this to the main.tsx. So I'm going to copy all of this stuff right here, and this needs to go into the entry point of the app. So that's main.tsx. So I'll put that all here. And then we need to render the router provider. So instead of rendering app.tsx, we're going to render the routes. This is going to be the entry point to our application. I don't need to import app.tsx anymore. And that is all set up in main. So I'm going to close main. I'm going to close a couple of these files. Now that's set up, the application is going to load in the route. So immediately it's going to load in the root route, and we'll get our nav bar, and then it will try loading in any of the pages. So if we're on the home page, it's going to load the index.tsx, so we'll see welcome home. But if we go to /about, we'll get the about page here, and we'll just see hello from about. And again, I was talking about that type safety. I have /about here because that is a valid page that I'm going to link to. But if I put in something else, TypeScript will complain saying, hey, you don't have this page here. So we get that type safety, which is really nice. And this extends to dynamic path parameters or search parameters. It has a whole bunch of really cool features, but we're only going to be looking at the basics here. So now if I go and view this in the browser, we should have lost the homepage, yeah. But now we have this new homepage. So if I'm just at the root route, we get the homepage. If I go to /about, it changes the path, and we see the about page. And we got to make sure that we use these links, because then it just navigates to the different components. It doesn't do a full page refresh. And then if I were to refresh the page, I'd still be at the same location. So this is really cool. But now we obviously want to load in that homepage we already created. So that was in app.tsx. So what I'm going to do is take all of this code out of app.tsx and put it into index. So instead of using this index function, I'm going to have the app function. I'll just rename this index, and I'm not going to export that. I'll move this down here. So everything is as it was before for the app route, but now we're exporting the route using Tanstack Router. So now this should be the home page, and then I can delete these two files. I'm surprised I didn't already delete app.css. And now the index page is what we already had set up. So it should just show the total amount spent. And then the about page is still just a fake about page. So let's see if that's working. So the home page gives me the total spent, and the about page just is a fake about page. So I now have routing set up, which is really cool, because now I can create some more pages. So I want another page for expenses. So this is going to show me all of the expenses. Show all expenses. And another page for create expense. I'm just copying and pasting about here, but I'll change these names just to make it a little bit more clear. So create. Oh, that's really cool. I didn't even know that was a feature. So if you create a new file and then just save it, it's going to autofill with some code for you. That's kind of cool. Okay. So I'll just call this create expense. Create expense. Okay, so I now have 4 pages: index, expenses, create expense, about. Some of these are just stubbed in. Oh, right, I didn't change the route to actually have that in the navigation. So I might just separate this out too. I'm going to create a function called maybe navbar that can manage all of the navigation parts here. And then this is just having the component right here. I'd actually prefer this to be its own component too. So I'll make function route and return that here. And then I could put these in separate files if I wanted, or do whatever I want really, but I'm just going to leave it all right here. So my route shows the navbar and then the outlet, and then I'm just going to have that be the component that is loaded. So now if I go back, I have my home and about still. Right, I didn't add the new links. I should add those. So let's make a link to expenses, and this is going to be exactly the same as the other one, but expenses, and then I'll create another link to create expenses, and this will be create, and it's not create expenses, create expense. So nice that it complains about that. Okay, cool. So now, yeah, got all the pages, expense, create, home, awesome. Okay, so now that I have all the routes set up super easily, I actually want to implement the create and the expenses page. So I'll start with the expenses page. When I go to this page, I just want to render a list of all the expenses that I have on the server. So I'm going to go into that page, into expenses, and Tanstack Router. There's a bunch of cool features in here. I do encourage you to look at the docs and check this out a bit more. You can provide a loader function here to actually load in your content before this page is seen, and then you can use suspense boundaries to make sure that people see a loading state before everything loads. But I am just going to continue to use React Query to load in all the state here. So I'm going to copy this from the index page since I already basically have this set up. So what I need is all of this code in my expenses page. So I'm just going to copy and paste that in, but this is my expenses component. And then instead of getting the total spent, I need to import the API from @lib/API. So instead of getting the total spent, we're just going to get all of the expenses. So that's API/expenses, and we're going to make a GET request there. Everything else here is going to be the same. And this should get us an object that contains an expenses property, and that is going to be an array of these expenses. So then down here, we're going to use query, and I need to import use query from Tanstack React Query. And you need to make sure that you update the unique key here too as well. So this is going to be get all expenses, and I should probably rename this function get all expenses. But that's basically the same. We're going to use query to go and grab that data from the server. And then I just want to present this quickly. So I'll say is pending else. Let's just JSON stringify the data for now, just to see what's coming back, and then we'll present it a little bit nicer in a moment. So now on this page, let's see. So yeah, if I added pre-tags to this too, it would look a tiny bit nicer. Okay, so there's the expenses coming out as JSON objects. Not what we want, but the data is correct. So that confirms that that is working, and I can see the fetch request working over here. It is grabbing that data correctly. So now I want to actually display these things. I'm going to go back to shadcn, and we're going to look for a component to display all these things in. I think table looks exactly what we want there. So I'm going to copy this code in and display it in the table. So first we're going to add that to the front end by using the shadcn CLI. And now I should be able to just copy this code and put it into my app. So let's see what this code looks like. We got a bunch of table stuff. I think I'm just going to copy this table stuff out of the table demo thing, and I'll move this all the way up to the top, and I'll put the table in here. So right now, this wants to display information about invoices. So I guess this is going to be data.expenses is going to be that array, and each of these is going to be expense. So I'll say the key is expense.id, and expenses right now just have a title and an amount. So that's all I really need. What did this table look like? Okay, so I'm going to display the ID, the title, and the amount in this table, and not worry about anything else right now. So then here we're going to display ID, title, amount. Let's see what that's currently looking like. Okay, ID, title, and amount. Cool. And then I should really get rid of this JSON stringify stuff here. So I think what I'll do is I'll move the is pending up a little bit. So if we have the data, I'm going to put it here. If it's pending, we won't show all of this data unless it's not pending. So that, let's see what that looks like formatted. Okay, so if it's pending, show this. Otherwise, show all of the table row stuff. And I'm not going to worry about the total right now. I'm going to keep this as simple as I can. And I'll just change this a list of all your expenses. Okay, so that's just grabbing the data and displaying it in a table, which I kind of like. Maybe I'll put a max width on this and margin auto. So it's just kind of of centered. Okay, that's cool. Yeah, I like that. I like how that looks. And if I refresh for a brief second, you can see those little 3 dots there. We actually simulate a longer delay if when we try to get all the expenses, we await server side. Actually, I don't even need to do this server side. I'm going to leave my server code alone. Back in my client side stuff, not using table footer, when I make this request, I'm going to simulate it taking a while by saying await new promise. And then we'll set a timeout for, let's do 3 seconds so we can see what it looks like. So it's going to show those 3 dots when it's loading. That kind of sucks. And then we get the table. That's nice. So if we go back to shadcn, we should be able to see a skeleton here. So we can use the skeleton to have placeholder stuff for the table. So again, I'm going to bring this component in using the CLI tool, and then we can copy a little bit of this code. So we're going to need really just something like this. So I'll import it up here, and then in my table, I'll keep all of this the same, but if it's pending, I'm going to take a table row, and maybe I'll display 3 rows by default. So let's say array 3, let's fill that, and I'll map it, grab the index and dump in a table row. The key is just going to be the index in the array. And then all the cells are going to be the same, except instead of loading real data, it's just going to show a skeleton. And I'm going to leave the width off. I think that should be okay. So here and here, each of those is going to display that skeleton. So if it's pending, show the fake version. If we have the data, show the actual data. So now if I go back and refresh, for that 3 seconds, we get the skeleton. That looks way nicer. And then the other stuff actually loads in. And then if I remove this stuff right here to do that fake loading, it's kind of janky because it's really quick to load in, but it's a little better than having those 3 dots. And if it does take a little while to load, that skeleton is going to look nicer. So we can get the total spent on the home page. I can see a list of all the expenses on the expenses page. Now let's add the ability to create a new expense. And for this, we're going to need to send a post request to the server that contains a title and an amount. And for this, I'm going to use a couple of the shadcn components again. We're going to grab input to get a consistent looking UI. So let's grab this for Bun. I'm going to bring that into the front end. And then we're also going to use the label here. So I'll grab that and also put that into the front end code. And then if I go to input, I think there's an example somewhere with label. So I'm going to grab this. I'm going to copy the imports and the actual label and input. So I'm going to bring this into the create expense page. And in this page, maybe I'll keep this in a heading, and then I'll throw the placeholder input code there, import the stuff I need up here, and wrap this in a form. So we're not going to use email. The first is going to be title, type text, and placeholder. I guess we just have title there. And then we're going to have another one for amount, and this is going to be number, and we're going to also need a button. So I'll import button from component /UI/button. This is going to be type submit, and maybe I'll just say create expense. All right, let's see what that looks like. Okay, not bad. Out of the box, not bad. Let's set the max width and do margin auto. And then I think I'll just add margin top of 4 on the bottom, give that some space. Okay, that looks fine. That could probably be much thinner too. Let's just go XL. Okay, that's cool. So if I input a title and an amount and then hit submit, I need that send a post request to the server. To get this working, I would need to store the inputs in state, listen for the submit event on the form, and then send a post request to the server. But there are a lot of other things that we have to think about when submitting content through a form. So when we hit submit, it's going to be in a pending state as it sends that data to the server. When the server responds, it could be in an error state or a success state, and we're going to need to notify the user of if things were successful or if they weren't. And then on top of that, the inputs might have validation criteria, and we want to tell the user if they've input something incorrect. Like, for example, the title might need at least a few characters to be valid, and maybe the amount needs to be a positive integer for it to be valid. And we only want to allow the form to be submitted submitted when these things are valid. So there's a lot of things surrounding forms that we don't want to have to implement from scratch. So instead, we're going to use a form library. And since we're already using Tanstack for querying and for routing, it would make sense that we could also use Tanstack Form. So I'm going to go to the docs here and we're just going to do the same thing that we've already been doing. We'll start with installation, install Tanstack React Form, bun add. I think the overview has pretty much everything we need. So I'm gonna bring in these imports here. And at the top of the component, we need to create a new form using use form. That's gonna have some default values here if we want. So we'll have a title, which can default to an empty string, and we'll have amount, which will default to 0. And then here's where we're gonna handle the onSubmit. Right now, we'll just console log to make sure everything's working. And then we'll implement the rest of this code here. So we need to wrap the form in a form provider. So right here, I'll wrap that there. And then we're going to use this onSubmit in the form that I've already got set up. And I need to close the form provider. And then for each of the fields, we're going to wrap that in a form field. So I'm going to copy one of these examples and then remove everything that I don't need. So the first form field is going to be for the title, and it was complaining because it knows that I don't have a last name in my schema here. So I'm constantly getting that type safety from these libraries. So the first thing is going to be the title. And then within this children's section here, I'm going to put my own label and title. We're going to copy the defaults here. So instead of assigning my own IDs and values and managing state on my own, I'm just going to copy the example here. So the ID should be the field.name, and it's going to generate an ID for me. So I put that in these two places. I can remove this label now. And then actually everything in this input is going to be basically the same. So I don't even think I need that placeholder. So I'm going to take that out. I'm just going to replace the default input with the shadcn input, and that should work. So the ID is going to be whatever the field name is. The name is going to be the field name. The value is going to be managed by the form state. And then we're setting on blur and on change so that it can do validation stuff. And it wants us to use this field info component that was defined at the top here, which is the most basic implementation of showing someone the validation state of the current thing. So if we're saying that title must have a few characters and they don't enter anything, this section right here will handle displaying any validation errors to the user. So each of my fields is going to be wrapped in a form field, and then I still use the label and input as before, and then my form has to be wrapped in the form provider. So I'm just going to copy what I did here and do the same for my amount field, where I wrap it in the form field, but this is going to be amount, and then underneath the input, I'll close this off in the same way, but I also need to close the fragment. Input is going to look exactly the same. Actually, I'm just going to copy both of these and paste them in. So the label is actually going to be amount. The type of this input field is going to be number, not text. And since everything in the input is text by default, not a number, I need to convert this to a number. You can do this in your favorite way possible. You can use plus, you can use double tilde. Probably better off just using number though. So now that's going to be a number. And then if I wanted to show validation errors to the user, I could put that here. Even though right now we're not validating these inputs at all, we will do that a little bit. But right now we're just going to leave this in, even though it won't really do anything. But if I submit this form now, all the state is being managed for me. So when I console log the values of the form, this should just work. So let's put in a title, leave the amount as 0, and open the console. And when I create expense, I can see that those are the values being logged to the console. So I get both of those values now. So one more thing I want to do before I actually submit this to the server is I'm going to copy the code from the example for what they have for the submit button, because this will allow us to check if the form can be submitted and if it is currently submitting to the server. So we can have our own loading state here too. I am just going to make this button the shadcn button with the same styling. I can delete this button here. So this will still look the same, still a submit button, but let's say it's taking a while to submit to the server. So let's put in another fake await for, let's say, 3 seconds. So if we submit to the server and it takes a little while, this submit button shouldn't be able to be clicked multiple times. So it should be disabled. And we've also set it to be a little loading state. You can set that to be whatever you want. But every single time I submit, it's now going to disable that button and show me, indicate to me that it is currently submitting to the server. Then if there were errors or validation errors, we could display that to the user. But now let's actually send this to the server. I'm going to leave this await in just so we can see what a long task would look like. So I don't need this, and I'm going to bring in the API from @lib API from, and then right here we are going to make that request. So await API.expenses.post, and we need to pass in the values. Is that the correct? No, it's saying, oh, we need to tell it that it's JSON that we are passing to the server, and then it's validating, yeah, that is the correct type that it's expecting on the server. Another thing I would want to do is just make sure that if it's not okay, we're going to throw an error in here saying that const res.okay, saying that something went wrong. And then we don't really need to console log the values, but essentially in here, we're going to make the request and we're going to make sure that it always throws an error if anything went wrong. And then our form submission will be able to handle those states for us. So now when I submit, it should be successful. We should get a new expense created. So let's put in an amount here. Let's say 6. So I submit that to the server. If I check the network tab, we should see 201. It seems to have been created. And then if I go to expenses, I should see that in the list. There's a title. And then if I go to the home page, that has been added to the total spend. And if I create another one, let's make this 10 and submit that, I've got that fake loading for 3 seconds, then it's successful, and then I go to expenses, I can see another one. Okay, so that's all great, that's working, but I kind of want to change this behavior just a little bit, because on successfully creating a new expense, I should either clear this form and let someone create a new expense again, or maybe redirect them to a new page. So I'm going to redirect them to the expenses page when they successfully create a new expense. So from React Router, I'm going to bring in the use navigate hook, which we're going to call right here. This will give us navigate. And then we're going to use that in the on submit. We're going to say navigate to, and then we'll go to expenses. So on successful submission, navigate to expenses. And now if I go in here, a title, some amount, I've still got that fake loading in there. So for 3 seconds, but then it should send us to the expenses page. And there I see my new expense. So that all seems to be working. We can go to the different pages. I can create a new expense. I can view the expenses. That's all working. We've got everything set up pretty well to expand on this more too. So adding this form provider now will make it much easier when we start adding more to this a little bit later, when we actually have a real database and we'll actually validate all of these fields first. And having these routers set up is going to make it really easy when we add auth to this, and we make sure only a logged in user can create an expense, can view their expenses and view their total expense. So we've still got quite a bit to add to build on to all of this, but we've got a pretty decent foundation at this point. And right now, I just want to make sure I can still deploy this to Fly.io. So I'm going to go back to the back end of my application, and I'm going to run fly deploy. And this should build my front end in that Docker file. It should build the front end, set up everything for the back end and the front end to work, and then deploy that to the server. So once this is done, that should all be working. I should be able to navigate around the different pages, and we should be able to see this thing live. So that's now deployed. It comes with the default expenses in the array in the back end, but I can navigate to all the pages. So the routing is all working in production. I can create a new expense. At least I hope I can. Let's say 100. Oh, I left that fake loading in there. That's okay. It redirected to this page. I have all those expenses. It gives me my new value. So this is all working. So now the next thing is to add auth to this so users can sign up and log in, and add a real database to this so it's actually persisting data and becomes a real application. For Auth, we're going to be using Kind, which is an Auth service. And I've been using Kind for a while now. I really like it. It's a really good service. And the reason that I always like to use an Auth service for my applications is because Auth is difficult to implement correctly, but implementing a service like Kind is really easy. If you want users to be able to sign up using their email address or a phone number, then you need to have some sort of email service or text messaging service so that you can send them forgot password links, or if they don't use passwords, then you have to send them auth codes. You also need a way of managing things like two-factor authentication, and it's really nice to have a user dashboard where you can see how many users you have, how often they're interacting with your application, and if you need to, you could potentially suspend a user or delete a user. So all the things surrounding auth and user management can be managed by a single service. So the first thing that you should do is sign up and log into your account. I am already logged in, so I'm going to go to my businesses and we're going to add a new business for this expense app. So I'm going to call this my new expense app, and the region I want this to be in is the one where my users are going to be. So I'm going to put this in USA and click save. This can only contain letters and numbers. That's fine. Let's just save that. And if I was doing this for a real application, I would actually set up a custom domain there, but I'm just going to select this application that I made. And then we're going to walk through some of their setup steps. So we're going to use Kind with an existing code base, click next. And then it has some options to help us get set up really quickly by providing us with front-end and back-end frameworks that it can integrate easily with. And in the front end, there is a React option, but I don't want to use an auth service from the front-end application because that makes it much less secure. Auth should probably always be done through the backend if we have a backend server. So instead, we're going to have the backend Hono Bun code manage everything to do with auth, and then the front end can just communicate with the backend if we need to log in or get user details or anything to do with the user. So they don't have a Bun option. I don't know many services that do already have Bun or Hono because they are fairly modern. So instead, we'll just select Node.js. It doesn't really matter. It's just going to help with the setup, and we're going to have to do a custom setup anyway. And then here we want to decide how the users can sign in. So by default, it's selected email, but ideally we would just have users log in with a social provider, and then we wouldn't have to deal with their email addresses, think about passwords or two-factor auth or anything. Because if a user's already set up their Google account and have a strong password there and two-factor authentication, it's way more secure for them to just have that single sign-on and use that for every other application. However, it's really common that people want to be able to sign up with their email address, or you're working for a client and they want to allow people to sign up with their emails. So we'll select email and I'll select Google login as well. And then we'll just explore on our own right now. So here is the application that represents the app that we're working with right now. And if we set up another server for this app, or maybe a mobile app or something, we might add another application, but this is all we're going to use right now. So I'm going to view the details. And if I go to quick start, I'm hoping, so it gives me the environment variables that we need right here. So the first thing we're going to do is copy these into the server project so that when we go through and start coding, we'll have the details that we need to get set up with auth. So I'm going to copy this, and in the root folder here, I'm going to create a new .env file and then paste all of those environment variables in. And by default, Bun will be able to pick up that file. So I'll leave that now. And the next thing we need to do is actually implement this in the application. And they don't have an SDK to work with Bun or with Hono, but if we follow the TypeScript docs, we can set it up just from their TypeScript library and their TypeScript examples. So the first thing we'll do is install the TypeScript SDK into the backend application. Then we're just going to kind of follow through the steps here, but I'll tweak the code as we need. So the first thing we'll need to do is actually set up a Kind client and then use that for pretty much everything. So I'm going to copy this code block, and in my server, I am just going to make a new kind.ts file and paste that in. And this file is going to manage all of the kind code. And then these values are all going to be coming from the environment variables. So I'm going to replace all of these strings here with process.env. Those environment variables that we copied already. And since this is TypeScript, I need to tell it that those definitely have a value. Those won't be optional. They exist in the file. And we will need to make sure that that these environment variables exist wherever we end up deploying the app. So in this case with Fly.io, I'll need to tell it that we have these details. So if we scroll down, we're gonna use some of the Node.js examples. They have Express here as the standard template, but we can copy these and only have to tweak them slightly to get them working with Hono. So in my app TS, I have my expenses route. I'm actually gonna make another route here. I'm gonna make an auth route, and every single route that deals with logging in, registering, anything to do with the user stuff, I'm gonna put in here. So first I need to import Hono, and actually this is gonna be pretty much identical to what I've done over here. So I will import Hono and create a new route like this. So I'll call this auth route. And we're just going to append all of the GET requests here. And then instead of rec-res, we end up with a context object, and then we're going to return context redirect. And then we need access to that kind client that we had over in the kind.ts, so I can just import that object in. And I don't think I actually exported that. Yeah, so we should export that object. Okay, so we're exporting that. We're grabbing that in here, and then it needs a session manager. So did I skip a step, or we're about to get to that. Okay, perfect. So I'm going to copy this in to the kind.ts because this is setting up a session manager, and I guess it wants us to bring in the session manager from kind, and then I can export this from my kind file as well, and then I'll import that in here too. I'll explain what's going on in a moment. I just want to get rid of all the red lines. So when I make a request, actually I guess I need to bring that into app as well. So we'll import the auth route from routes/auth, and then we'll pen that here. So we'll always go through API. /API/login will trigger the kind login, and /API/register will trigger the kind register. So these endpoints are pretty basic. We're just going to use the kind client to either log in or register. And then in the kind TS, we set up the kind client object. And then here we have the session manager, because kind doesn't really have an opinion right now on how we store the session details. So when we log in or register with kind, it's going to give us some tokens that identify and authorize the current user. And how we store them is completely up to us. And right now it's just going to store it in an object in memory. But what I want to do for this app is store all those details in a cookie so that every request we make from the client will contain the user details, so it'll be really easy to authorize with the server. And it's also common to have a React app store them in local storage or session storage, but I prefer using cookies for all of this. So I'm going to update this code with some code I wrote earlier. And to get rid of those red lines, I'm going to need to import all of these things. So we've got a type from Hono, and then all the cookie stuff that is going to be handled by Hono. Down here for the session manager, any single time kind gives us a new token from the service, we're going to store that in a cookie in the browser. HTTP only, so it can't be accessed by JavaScript, secure, so we have to have an SSL connection, and same site lacks to avoid cross-site forgery attacks. So this is just making sure that we can set the tokens as a cookie, and if we need to remove the session or destroy the session, we can just delete the item out of the cookie, and then when we need to get any of those details, we get them from the cookie. So this is all just dealing with this as a way of storing the details in the cookie. So now in my route file, the session needs access to the current context, so I've just set that up to be a function that now accepts the context object, but everything else should pretty much be the same. And we're going to hide all of the complexity about kind in the single kind file. There's not too much more code we'll need to add here. Then the rest of our application will just be able to access the kind client anytime we need to do anything with regards to the user auth. So let's finish setting this up. The next thing we want to do is implement the callback function. So this is what kind will call /API/callback once it's done logging a user in or registering that user. Again, we're going to c.redirect with the context object, and the URL is just going to come straight from the context object too. So this is going to be c.rec.url, and the session manager we need to pass the context object into. So we can log in, register. We are handling the callback from kind, and this will get called every time we log in or register, just in case you need to to do any custom code after a user logs in or after they've signed up, you can do that in here. Then the thing we're missing is logout. So let's see, yeah, that's next. So I'll copy and paste that in here and then do the same things. Call the session manager with context. Okay, so I think that's all the routes we need. And then here's some code we can run to see if the user is authenticated or not. So I am going to add another endpoint here. I'm going to add get/me. And if I call this endpoint, I just want the server to tell me if I am logged in, and then maybe it can also give me my current details like my name or email or something. But right now I'll just have this return is authenticated. Yeah, I'll just return that. So at this point we should be able to log in, we should be able to log out, and we should be able to check with the server to see if we are logged in or not. Now, we just have to go back and make sure the application is configured correctly. So if we go into details and scroll to the bottom, here we have allowed callback URLs and allow redirect URLs. And we are doing everything from the Vite server, remember. So this has to be 5173 for both of these. And I've made it /API/callback. So you got to make sure these match the URLs of your environment and then click save. And now if I go back to my application, I'm just going to make sure the front end and back end are both running. So if I go to /API/me, it should tell me that I'm not authenticated, and nothing happened here. And that's because I didn't actually add my auth route. So that was bad. Oh, and actually I don't want this to be auth route. I just want this to be /. So if I go to /API/any of these, it should just go straight there. Okay. So that should now work. /API/me should show me that I am not authenticated. Perfect. And now if I go to /API/register, I should be able to sign up, but it's saying I have an invalid URL. And that's because in my environment variables file, I was supposed to update these as well to be 5173 and /API/callback. So after I update those, I'm pretty sure I should restart the Bun server. And then let's try this again. So I'm going to go back and I'm going to try /API/login. And yeah, it gives me this login page. Perfect. So I can choose to sign in with an email address or my Google account. I think I'm going to go with my email address. Oh, I don't have an account. I guess I went to login instead of register. That's fine. All right, so let's go first name, last name, email address. And then the way this works by default is it does passwordless auth. So instead of having me choose a password, it's going to email me a code every single time, which is more secure than remembering a password each time. But I could opt to do passwords instead of this. But I do now need to check my email address on a different window. And then I can paste in that code and continue. So I should now be logged in, and then my redirect URL was just go straight back to the home page. But now if I check /API/me, it should tell me that I am authenticated. And then if I go back and log out, it should log me out, and then I can check these API endpoints again, /API/me. I am not authenticated, and if I wanted to log in, I would have to redirect to /API/login, where I could log back in again with my email address, get a new code, paste that in, and continue. And this all seems to be working perfectly. And if I go and check the application tab, we should be able to see here are all the cookies. So it gives me an access token, ID token, refresh token, and a user token. So these are all stored in the cookie. If I log out, it's going to remove these from the cookie, but this is what it's using to check if I'm logged in or not. So one more thing I want to do right now is when I go to /API/me, instead of just telling me that I'm logged in, I want the server to tell me who I'm logged in as. So I'll go back to my auth route, and right here I'm checking is authenticated to see if I am logged in. If I'm not logged in, I think I just want to say, let's return c.json. Let's make this an error. We'll say that you are unauthorized and send back a status code of 401. That's a pretty standard thing to do if we're trying to access my current details and I'm not logged in. But if I am logged in, then we can grab the user details from the kind client by calling get user and passing in the session manager. Instead of initializing this twice, I think I'm just going to create a variable and pass that into both of these functions. And then I could return return c.json user. So check if I'm authenticated. If I am, grab the user details and send that back. So now if I refresh, I can see those details. That is coming back as a string, not JSON. Let's see, I probably got the wrong function. There's a bunch of functions here. I think it's actually get user profile. Yeah, that actually gets me the user type. Awesome. All right, so those are the details. That's the unique user ID. We're going to use this in the database later. That's the name I signed up with, my email address. I don't have a picture with Kind, but I have a first name, last name, so awesome. And checking if the user is logged in is something that we're going to want to do in a lot of the routes. Like all of these expenses routes should only work for a user that is currently logged in. And on top of that, we're going to want the user ID, so the user details on each of those routes. So this is going to be something really common that we're going to want on every single authenticated route that we have in the backend. So what we're going to do now is create a middleware function using Hono's custom middleware. So I'm going to bring this in and we're going to do this in the kind file so that this can be shared with all the different routes. So I'll import this at the top and then we're going to create a new middleware factory function. And then from that, we can create some middleware. So this is just the default stuff. The thing that we're going to want here is a user object. So if I have authenticated middleware, I want the user to be passed in to every route that is using that middleware. So from kind, I'm going to import the user profile type, and that is going to be the type that this middleware function uses. I'll rename this to get user. That's going to be the name of the middleware function. And then essentially we want to do everything that we did in the get me route. So I'm going to copy all of this and put it into the middleware function. And if the user is not authenticated and we're using this, we will just send back a 401. But if the user is authenticated, instead of returning that user to the client, we are going to set the user variable that we have up here. So that's what this middleware function is using. We're going to set that variable to be the user profile. And then we can call next. And I think we actually want to await that. And just in case anything goes wrong, we should probably put all of this in a try catch so that we can console error the error. And if there's any issues trying to figure out who this user is, we will just say they are unauthorized. So now we have this get user. And actually I did this wrong. I didn't need the factory. I should have just put the env there because we're just creating a single middleware function in this case. And now it's giving me a TypeScript error because I messed up the types. Oh, cool. Okay, nice error. So it's not the user profile I'm bringing in, it's the user type from kind. That is the type that we get when we grab the user from get user profile. Perfect. Okay, so now any API handler should be able to use this middleware function. It's just the same stuff we were doing before, but now let's see. So we can import this into the auth routes from kind. And now it works just as you'd expect middleware to work. So when I want to get the user profile, I'll just make sure I call that middleware function first. Now I don't need to do any of this because the context object will now have access to any variables that I've set in middleware functions, which right now includes that user object. So if we check this, we can see the user has that user type. This logic will only get executed if the user is logged in and we could get their details. And now I can send that back to the client. So we're keeping the routes pretty clean. It's pretty minimal amount of code here. We've put all that logic that we need just in this kind file here, and it's still only 72 lines long. So implementing all this auth isn't that much TypeScript code. So let's make sure that still works. We can still get all the details. So now what I want to do is actually display this in the front end of the application so that we can see that all working. We are going to make these protected routes in the front end and in the back end, but we're going to start slow. So the first thing I want to do is set up a profile page in the front end, just so we can see how this will all work together. So I'm going to copy the about page because that's a basic page. I'm going to rename this to profile, rename these things to profile. And then we want to make a GET request to /API/me. So I'm just going to copy the code from the index.tsx so I don't have to rewrite all all of that. So we're importing the API. We're going to make a function to get current user, rename this, get current user, and the get request is going to be to API/me.get, and I'm gonna need use query from React query. Put that in the profile component, delete that. And now the way I'm expecting this to work is if it's pending, we're just waiting to see if the network request is going to complete. If there's an error, then really the user is not logged in, or most likely they're not logged in. But if we get down here, then we have the user data and we could present something to the user. So I could say hello data.user. Let's see, we have a family name. That looks good. So I should be able to present details about the currently logged in user. And if we get an error on this request, then we'll assume they're not logged in because we get that 401 if they're not logged in. So I'll also add a profile link into the nav bar, profile. So now, yeah, I should be able to navigate to the profile page. And it says hello from profile and then says hello, and it gives me my last name. So that is how we're going to check if the user is currently logged in from the client. And this is going to work just fine for a single page. But if we want to use this on multiple pages, there are two big issues. The first is that I don't want to have to duplicate this code for every single page where a user has to be logged in. And every single time we navigate between pages, I don't want to keep getting the current user. Really what should happen is I load up the web page, it makes that request to check if I'm logged in, and then it doesn't need to make that request again unless I log out or I completely close the window and then come back. So the first thing I'm going to do is in my lib API file, I am going to take these query options out of here. I'll copy this whole thing, and we're going to define them in this file. So const user query options equals, and then this is going to be query options from Tanstack React query. And then I'm also going to bring in this function so that these two things can at least be reused. This is the function grabbing the user details from the server. This is the React query configuration when we get those user details. And I'm going to set the stale time to be infinity. So the moment one component uses these query options, the result will get cached until we manually invalidate that cache, or the user refreshes the page, which will happen when they log in or log out. So this will be completely sufficient for the current way that we're authorizing the user. Now, any file that wants to get the user details can just import this from the API file and then use query like this. So now the request will only ever be made once, and this is still a pretty trivial way of just checking if the user is logged in, but we can still do better than this. And it's actually giving me an error here. I must have forgotten to export it. And then I'll go back to profile and let's just double check that's working. Yeah, so I can refresh and I can navigate about, and that network request shouldn't be made again. So if I navigate to home, navigate to expenses, it is going to make those requests again because I haven't set up any caching for those yet. But if I grab the profile details, we should be able to see that we never grabbed the profile again. It just happens the first time and then when I refresh the page. So like I said, we could just put this at the top of every file that we want to be an authorized route and then just tell the user they're not logged in, or maybe redirect them to the login page. But we can put this stuff in a single location and not even allow the user to get to certain pages if they're not logged in. So to do this, I'm going to follow the guide for authenticated routes in Tanstack Router because there's a couple of examples here. So I'm going to copy the first code block and I'm going to make a new route in the routes folder called _authenticated. And any route that starts with an underscore is not actually a page. It's going to be a wrapper around any page that starts with _authenticated. So if I want to make authenticated routes, I would just have to prefix any of these other routes with _authenticated, because here I'm going to put in all the logic that I need. Just import file route. I'll put in all the logic I need to verify that the user is authenticated before they can continue on. I'm going to bring in a little bit more code here from the example. So we're going to see a lot of red for a while, but let's kind of pseudocode this out for a moment. So this is going to be a wrapper around any authenticated routes. Before we load this route or any of the child routes, what we're going to do is use those user query options to check if the user is logged in. Then when we're done with that, we can pass in the result here. So we can pass in, let's say, the user object, and this is where we render the component. So if we have no user, if the user is not logged in, we'll return some sort of login component. We'll show them a login screen where they can go to the kind login page. But if they are logged in, then we'll just continue as normal and render whatever the page is supposed to be. So I'm just going to fake this just so we can see what's going on here. So let's pretend the user is logged in. We'll return a valid user object. I'll just give it a name for now. Then in the component, I would actually grab the user like this, and this will work better if I break this component out into a function and then reference that here. Okay, so this is the component that will be rendered. I'm also just going to make a fake login component that for now, let's just say you have to log in. And then outlet comes from Tanstack Router. Okay, so before we load the page, there's two options. We can either be logged in or we could return null for the user and not be logged in. So let's check this state first. So before we load, grab the user, return the user out of this before load function, then the component that this renders has access to that object. If we found a user, if we request that from the server and we have the user, then we're going to render the pages as normal. If we didn't find a user, then we'll just render this fake login page for now. So this should already work. We're not making a network request, we're just faking it here. But right now, any authenticated routes should just show this login page because I've set user to null manually. So the way we can make authenticated routes is prefix routes with this underscore authenticated, or a nicer way would be to make a folder called underscore authenticated. It just has to match the name of this file here. And now any routes that I want to be authenticated, I just put into this folder. So I want someone to be logged in before they can create an expense, see expenses, see the home page and see the profile page, but I will allow the about page to be viewed by anyone. So I'm just going to move those into that folder. And now if any of these pages are requested, this file first gets executed. We check if the user is logged in, and then we navigate that person either to the page or to the login screen. So all of these pages now should be showing me a login screen if I try and visit them. So the home page says I have to log in, about says I have to, oh no, about's okay. Expenses says I have to log in, create, profile. These all say I have to log in to see these pages, but about is the only not authenticated route, so I can still see that page as normal. And that checks out because it's the only one out here. So that's how I make authenticated routes. I think these are complaining because the routes changed, and sometimes the route tree.gen just opens itself up and you have to close it, don't save it, save a file and everything will go back to normal. And to double check this is all working, let's pretend we are logged in, and I will pass in a valid user here. If there is a user, we just present the pages as normal. So now I get normal homepage, expenses, create, profile. Perfect. Okay. So now I just need to make sure that this is actually performing the HTTP request to the server to get the actual user. And we're going to do that with the query object from Tanstack Query. So I need access to this query client here. And the way we do this is we can pass in context to the router here. So we've passed in the route tree. That was just the boilerplate code we set up. But if we want every single page to be able to access some sort of object, some sort of data, in this case, the query client, we can pass down context to every single one of those pages. There's just one more thing we need to do to make sure we get type safety with that. Create the root route with context. So I'm going to copy these two things. We're going to go back to the root, and I need to create this as a root route with context. I'm going to copy in that interface, my router context, and then we invoke this as a function and then pass in the rest of the stuff. And I need to grab query client type from Tanstack React query. So this is just specifying what the type of data is going to be in the context object, but in the main.tsx, we can pass in the data that goes into the router context. But this does now mean that every single route, including my authenticated route here, is going to have access to that context. And in the before load function that routes get, we just have access to that directly in context. That gets passed in. So now the query client that we're using should be available on context.query client. And the only reason I have to use the query client instead of use query is because this isn't a component, so I can't use a hook in here. So now from the query client, we can fetch query. We're going to make sure that we're always using the user query options so that if we fetch this somewhere else, we're not actually making the API request again. We can grab the user from that, and this user is actually going to have the user object on it, so this is more of data. So if this is successful, we'll have an object with the user details on it. So right here, I can just return the data, and that is going to give me the user object there. I can remove all of this, and then I just need to handle the error case. So if this fails for any reason, the most likely one being that the user is not logged in, I'm just going to return user null. So this is what is determining if the user is logged in or not logged in. And it also gives us access to the user details. So now that should all work. If I'm logged in, I should be able to see everything, which I can. And then if I'm logged out, I won't be able to see anything. So let's quickly add in on the login page an href to /API/login. And we want to make this a normal link because it isn't a page within our application. It is going to go to kind servers to do this. So that's just a login button. And then we'll do the exact same thing on the profile page. I'm going to allow a user to log out. So now I should be logged in, but I have a logout button there. I can navigate around all the pages. If I click the logout link, it should just log me out, and all of these now become protected routes. I can't access them, but I can click this login button and then go through that login process again. And then as soon as I'm logged in, I have access to my details, so I can view all these pages and I can view my details on the profile page. So this is how we're managing the currently logged in user state. And the only thing really left to do with regards to Auth would be to go to the backend routes for expenses. And I want to import that get user middleware from kind, and I want to attach this to every single route that requires me to be logged in, which is really every single one of these. So I'll add those all in, and now I won't be able to make any of these requests unless I'm actually logged in. And I can also grab the user details from c.var.user, and then I'll use the user ID to grab expenses only for that single user, and the same thing for the rest of these routes. But for all of that to be more meaningful, we should set up a real database, which we'll do in a little bit. There's just a few things I want to do first. Let's clean up the UI just a little bit in the front end. And I'm just going to make some max widths with some margin autos. So we'll start with the nav bar. Actually, I'll just do this around the outlet too, and then that should bring everything in a little bit. I don't want the flex. Okay. Yeah, that all seems fine. Profile page could be nicer and the login page could be nicer, but I think that's good enough. And then the next thing I want to do is actually deploy this app to Fly.io so we can see that it actually works deployed. And back in kind, I've set up the URLs to only be the localhost URLs. So I have this as my production environment, and I could create a dev environment and a production environment. But to keep things simple, I'm just going to have one environment for everything for now. And then I can always add more environments later on anyway. So I'm going to grab my deployment, my production URL. I'm going to copy that and paste it into my details here. So the entire URL will be my allowed logout URL. And my callback is going to be the same thing, /API/callback. And then I'm going to save these two like that in kind. And then I need to send those environment variables to my Fly.io server. So I'm going to go to Fly.io and see how we can do this, because we can actually set all these environment variables as secrets with one simple command here. Perfect. So if I run this, I'm going to need to change the file here, but I'm going to run this from my backend directory. Basically, we're going to tell it to import the .env file that we have, where we have the environment variable set up. it's going to store all of the environment variables as secrets, so they're going to be encrypted on Fly.io, but they'll still be accessible through process.env. So this is all we have to run to get all the local environment variables on the server. Or if we wanted to set different environment variables, I could say flyctl secrets set, and then I could just specify a secret equals whatever, and then that would set it for the specific application, but we're just going to use the same ones we have in .env. So now I should be able to say fly deploy, and this will deploy the app with those environment variables, and we should be able to use the app as we did locally, log in, log out, and view the authenticated pages only if we're logged in. So now that's deployed, I'm going to refresh. Okay, so it says I have to log in. I did not fix that login page. All of this seems to be working. So let's click login, and I got an internal server error because I didn't set my URLs in my environment variables to be different. So this for production needs to be my production URL, which is going to be this. So my redirect URL is going to be that and that. So now I need to set these as the secrets. So I'm going to run fly secrets set and then paste that in and do the same for this. Okay, so those are both being set, and I really should have checked that before deploying, but that's fine. It's one benefit of deploying incrementally. You can catch the bug that you were just working with in the moment that you're working with it. So that's nice. Okay, so that should all be updated. Let's click login, and it logged me straight in. I guess it must have cached those details from logging in with localhost. So I'm going to log out, make sure I actually get to the login screen. Perfect. Okay, so I can log in here, go through the login process, and now I'm able to access the rest of the site. And if I go back to Kind as well and go to the dashboard here, I can see the single user that's logged in. I can view their activity, delete or suspend the user, and I can see all the users that ever sign up to the app. So that's all working now. That's great. We have Auth completely set up. So now it's time to add a database. And before we do that, let's talk a little bit about how we actually deploy apps. So we have all the server-side code that we've written, and we need to deploy this code to a server in the cloud. And this could be a serverless function or a container or a virtual machine. It doesn't really matter because the plan is always generally going to be the same. We're going to get users to our application, and they are going to visit the app by making a request to our server. And then if we get lots more users making a lot of more requests to our server, the plan is always going to be to copy our code to another machine or Lambda function or container. It doesn't really matter. The way we handle more load is to have more instances of our code running to be able to handle all the requests. And this works the other way too. If we get no users using our application, we'll scale this down, and we can even scale all the way down to 0. And this is why most services don't cost any money when you don't have any users, because it's pay for what you use. So this is a really decent plan for scaling up. You just run more instances of your code to handle more users. But this does mean that you can't persist any data on any of your servers or containers or functions, because at some point that data will get deleted. So we have this space where all of our compute exists, and we need to have a plan for our server-side code to be able to access file storage from some other location if we're dealing with images or static assets like that. And we also need to have a plan for where the database is going to exist, because all of our server-side instances are going to need to access the same database, but the database is going to have the same problems where it needs to scale up and down depending on how many users we have, but it also has to persist that data. So really what we want to use is a database service that manages all of that scaling, all of that replication, anything to do with databases we want to be managed for us. So we're going to use a database service, and I asked online and everyone voted for Postgres. So what we're going to be using here is a Postgres database service. And you could have a Postgres instance installed locally on your machine for local development, but when we end up deploying the application, we're going to need a cloud Postgres database service. And the one that I'm going to use in this tutorial is going to be Neon, purely because they have been one of the the easiest services to get set up with. But if you have your own opinions on which database you would like to use or which service you would like to use, you can use whatever. But I'm going to be using Neon and Postgres for the rest of this. And this will mean that when we go to deploy the app, everything will just work. And then we also need to think about what the database is going to look like. So right now we only have a single table. It is for expenses. So we have an ID. This is going to be serial, which is going to be an auto-incrementing integer in Postgres. We're going to have a user ID. And if you remember from the response that we get back from the server, the user ID is going to be this string here. So we're just going to say that the user ID is a string. We currently have a title, which is a string, and an amount. And the data type for the amount is going to be special because this is for monetary values. So if we check the Postgres docs, there are a few different types they have for storing numeric values. There's integers, decimals, reals, doubles. So which type should we use for money? We don't want to use integers because those are whole values, and it would probably be okay to use an integer, but then we would always be storing the amount in cents instead of in the dollar amount. So it'd be nicer to use something that has decimal values, but we can't use floating point values because those are inaccurate. We can easily see in a JavaScript console, if I add 0.1 to 0.2, we don't actually get 0.3. So this is unacceptable for monetary values. If I check monetary amounts here, Postgres suggests using numeric with a precision and scale. So this is the amount of values we can have, and this is the amount of values that go after the decimal point. So if we go in here and we choose numeric 12 2, this will give us enough values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 for the decimal. This will give us enough to store $1 billion. So I think that might be enough for this expense tracker. So I'm going to go with that amount in the database. And this is just an ERD. I'm not actually coding anything out here. I just want to visualize it before we actually start coding. So we're going to use Postgres. We're going to have a single table for now, and this is what it's going to look like. And then to connect to the database, we are going to use Drizzle ORM, which is a really great TypeScript ORM that is going to make it much easier to write SQL code. It's going to let us generate and apply migrations. It has this Drizzle Studio so we can view the database in a nice web interface. And there's a lot of features to this library. It's really worth learning. It's one of my favorites. This one deserves a whole tutorial on its own because we're only going to touch the basics here, but this is what we're going to be using to get the database set up in our application. So I'm going to start with Drizzle, and I'm going to go to the Postgres section, and we're just going to go to postgres.js because the Neon instructions tend to be for serverless environments, and we do not have a serverless environment right now. So we're going to bun add Drizzle and Drizzle kit to the backend application. And then we're going to follow through some of these instructions to get things set up. So I'll copy this code. We're not going to need most of that. But in the backend application, I'm going to go into server. I'm going to make a new folder called DB. And then in here, I'm going to set up an index.ts file. This will be the entry point for the database. I don't need any of this migration code. We will come back to this in a little bit, but all I really need is this. So we're going to set up a database object with Drizzle, and this is going to be set up using a database URL. And we're going to use an environment variable for this. So this is going to come from process.env, and I'll probably just call this database URL. So now I need a database URL. We're going to set that up with Neon in a moment. But first, let's finish looking at the rest of this. So I'm going to scroll down to the overview in the managing schema section. I think I'm just going to pull out the first example here and we'll modify it as we need to. So we have the index.ts. This is going to manage the connection to the database. I'm going to make another folder here called schema, and here's where we can put all of the tables. So right now we just have an expenses table, and I'm going to dump in the code they've given me. This has 2 tables, so I'm just going to delete the bottom one. I don't need an enum. It's going to be a really, really basic table. So I'm going to call this expenses, and everything in strings here is going to be what appears in the actual database. So in Postgres, this is going to be expenses. ID is going to be serial. It's an auto-incrementing integer, and it's going to be the primary key. We're going to have a user ID, which is going to be text, and in Postgres, that should be user_ID. And we need to import all the types. They're coming from Drizzle ORM PG core. So if you're using MySQL or SQLite, you would just be importing it from that specific part of Drizzle. I'm going to bring in text there. We're also going to want a title, which is going to be text title. Both of these actually should be not null. Finally, we're going to have an amount, which is going to be numeric. And I need to import numeric to use that type. Name in Postgres is going to be amount with precision 12 and scale 2. This is going to be not null. I'm going to delete this name here. I don't need it, but I wanted to keep this block of code at the bottom here because this is how we can create indexes. I want user ID to be an index on this table because I'm most likely going to be searching for expenses using the user ID for an equality check. Like grab me all expenses where user ID equals this user ID for the specific user. So we're going to create a user ID index. It isn't going to be a unique index. It's just going to be a normal index. So I'll bring that in. And this isn't called countries. It's called expenses. So we're using a user ID index on the expenses.user ID. And this is just a performance thing. If you know how you're going to be accessing data, you can just add indexes early on. So this is the entire table now. We can modify this later. The great thing about Drizzle is that we are defining the current structure of the table. So I don't have to say create table or alter table later on. I'll always just modify this object to be the current state of the database, and then I can apply a migration and it will always be whatever I've specified right here. And I get a lot of TypeScript safety by doing things this way. And if you wanted to check the docs, there are all the column types here. You can read through that. You can see what all the options are, but I have enough for the expenses table. So I have the schema defined. I have my database object being created. I don't have a database URL. I don't have a real database yet, but I can still code through my app using this and implement some of the things if I wanted to. So I could go to the expenses route and I'll just show you how this works. So I can import the database from database folder /index, which is actually /. And then I would also import my expenses table from db/schema/expenses. And then if in my expenses route, I wanted to actually select the expenses from the database, Drizzle would work like this. So I would go db.select, and it's just going to seem like normal SQL, but with all the type safety. So I'm going to select everything. I'm select star from my expenses table. And generally I like to store this in a variable where I would say const expenses equals. So instead of just leaving that as expenses here, I'm going to alias it as expenses table. So it's very obvious in this file that this is the table I'm talking about, and every time I have expenses, it's the result of calling a query. So select from the expenses table, and then you can add other things on. So I want to only select the expenses for the current user. So I can say where equals, and equals is a function I need to bring in from Drizzle ORM. So import equals from Drizzle ORM, and you can see this all in the docs too. If I went back to select statements here, you can see all the different options that you have, all the different functions that you can bring in. And if you know SQL, writing these queries is going to feel really familiar. So I'm going to do an equality check for where the currently logged in user, because we have that now, where the user ID is equal to the expenses table dot user ID. And I got that the wrong way round. I'm supposed to put the table one first, and now that works. And obviously this won't grab me anything because we haven't inserted any expenses into the database with that user ID. But this just goes to show that we can start coding out the application with type safety. This is going to tell me the exact type that I'm getting back, and it tells me that I've messed up. I'm supposed to await this. So this will show me, if I try to get all expenses, this is the type. I have an array of these types right here, the expense type. And we could go pretty far here without a database, just coding everything. But if I try to run this application, it obviously won't work because I don't have a real database. So I'll implement the post and the get just like that. Then we'll set up the real database, make sure those two things are working, and then we'll implement the rest of these. So if I want to make a post request into the database, it would be db.insert into the expenses table, and the values are going to be the expense that's being validated with Zod. So I'll destructure that because I also need the user ID. So this is a validated route. I can grab the user and then say that the user ID is going to be user.id. And this is complaining because I originally said that the amount was a number earlier on, when amount is now a decimal type. Now, this is a really interesting thing. The expense has a numeric amount. This is a decimal amount that exists in Postgres, but JavaScript doesn't have any sense of decimal values. It has doubles and that's it. And we can't use doubles here because they're not accurate enough. So this is actually going to be a string type in JavaScript when we get it back. And we'll see how to work with this table a little bit better in a moment. But for now, I'm just going to update the create post schema here to have title be a string just to get this working. And then I'm going to set all the amounts here in the fake database to also be strings. So in the database, it is still a numeric value. We can still perform some functions on it or any math functions on them. But as soon as it gets into JavaScript land, they're going to be strings to make sure that everything's safe. And I'm getting some errors from my fake database stuff. I'm just going to fix this temporarily in the worst way possible. It's always a good note to myself that this isn't a real fix. This is just a temporary fix for something. Okay, so now the insert should work. I'm not pushing into the fake database anymore. What I'm actually doing is inserting into the expenses table. This is just going to insert. It's not going to return the result back to me, but I can append a returning function onto the end here, and this will give me back the result of inserting this expense into the database. And then I could return that to the client if I wanted to. Maybe I will, even though I'm not really using it, I'll still just return that down. So now post will grab the data from the post request, grab the user details, and try and insert that into the database. The get request will grab all expenses and return that back to the user. Again, none of this is set up to work with a real database just yet, but we will get there. One more thing I should change is that in my front end, my create expense is probably complaining now because my value is a number instead of a string. So I'm just going to make sure that that is also a string all the time too. And that's a good thing because then the value that is input will be accurate all the way up to the database. So I've got some queries written here. I have my database code set up here, and I have a table schema set up in the schema folder. The only thing I really have left to do is to create an actual database, get a URL, and then hook this up to that real database so it can make queries to the database. So I'm going to go over to Neon, and I already have an account, so I'm just going to log in. But if you don't, you can create an account, log in. I don't care about the new plans. I'm going to make a new project. My expense demo Postgres 16 is good. I'm going to put this closer to where my application will be. That amount of RAM I think is good. I think that's what you get on the free tier anyway, so that's good. We'll just leave all the other settings as the basic settings and set up the database. Now I get this connection string, and this is all I need. This is why Neon is pretty easy to get started with. This isn't a production ready string. I would want to create a role and limit access. I get complete admin access to this database. But I'm going to copy this into my application. I'm going to go to my env file and create a database URL, env, paste that in. I'm going to put it in single quotes because this sometimes doesn't work unless I have it quoted. And now I have a database URL. So the database exists, but the table does not yet exist in the database, this expenses table. So the next thing I need to do is create a migration for this expenses table and then apply that to my Postgres database. Back in Drizzle, I'm going to scroll down to the migration section. And here is the quick start getting started with migrations. Declare your schema. We've already done that. Create a config file. So we need to create a Drizzle config TS file in the root of the project. So I'm going to copy that. I'm going to make sure that I'm in the root folder, the very root folder here, and we're going to make a drizzle.config.ts, paste in that code. This is going to be for Postgres, and the DB credentials can be a connection string, which is going to be process.env.database URL, and the schema exists in server/db/schema, which is a folder. So all the files in the schema folder, and we're going to output the migration files to a Drizzle folder in the root directory. I'm happy with that. So that looks pretty good. And then we should just be able to run Drizzle kit generate, and instead of MySQL, I'm going to put in Postgres or PG. So if I do this from the root directory, it failed because I don't need .env with bun. I completely missed that line. Okay, delete that line. So this is what the config should look like. I don't need this comment either. So now that should create a migration. Perfect. All right, so it said it created one table. We should have a Drizzle folder here, and inside, don't need the meta, we have this SQL where it's going to create the table. If we were to modify the schema in the TypeScript file over here for the expenses, then if we ran a new migration, we would get an alter table statement. So that's cool. Now we just need to run this against the Neon Postgres database. And to do that, I can actually take the code that it gave us in the beginning. So in index.ts, I commented out some code here. I'm going to take this out and I'm going to create a new file here called migrate.ts, and I'm going to paste that code in. The migration client is going to use process.env database URL, and then we just need to give it the migrations folder, which is going to be ./drizzle. And since I only ever run this as a configuration script, I don't put it in my source directory. I usually put it in the top level directory. So I'm going to run migrate. It's going to run the migrations from the Drizzle folder against the Postgres database on Neon. So now I can just run bun migrate.ts, and this actually needs to be in an object, migrations folder, give it that string, and this is also async, so I'm going to wait this, and maybe I'll also put a little console log at the end. Migration complete. Let's try running that again. Okay, perfect. Migration complete. The file didn't stop itself, so I'll just stop that. If I run this again, perfect, we get a little warning, hey, there's nothing to migrate. So that's awesome. That appears to have migrated successfully, and we could go into Neon and check this, but we can also use Drizzle Studio, which is something that comes with Drizzle, and it's a really nice interface of interacting with your data and your database. And to use this, all we need to do is run bunx drizzle kit studio. So I'm going to run this. Oh yeah, for some reason, Drizzle Kit Studio needs the PG package. I don't know why, but let's install this. Bun install PG, and then we'll run Drizzle Kit Studio. So it's available at this URL. And I can see I have an expenses table. That's awesome. So here is my entire database. It says I have an expenses table. I can see the schema here. I could put in some fake data if I wanted to, but this is just showing me that everything was set up correctly. So I still have the server running. I still have the front end running. If all the code has been set up correctly, I should be able to go to localhost 5173, and I'm currently logged in. So let's see, let's create a new expense, open up DevTools just in case there's an error here. And I'll just put in, say 10.50. Why not? Submit that. I still have that fake loading thing in there, so that's going to take a moment. And then it seems to have worked. It seems to be good. Expense went up. It was saved correctly. I have the user ID there. When we requested it back down, it seems to be good. And if I check in Drizzle Studio, I just refresh it, I can see that new expense was created. It exists in that Neon database in the cloud. There's the ID, the user ID, the title, and the amount. So all of that is connected up together. All of it's working perfectly. We just need to make sure the other endpoints are working as well, because currently getting the total spent is still pulling from that fake database. So I don't need that file anymore. I don't need most of these. I'm going to close them all. Back in the server, I have expenses, and I am going to delete my fake expenses. I don't need those anymore. We're going to make this all work with the real database. Get is working. We're selecting all of the expenses from the database. We would probably want to add some pagination at some point and limit this to a couple of expenses, maybe 100 at most. But I'm going to leave this off for now. That's something that you can implement if you want to. Actually, I would also always add an order by. Oh, you know what? We should add one more thing to the schema. What's really nice is always to have a created at column, and I'm going to check the docs for this because I am certain that they have a created at timestamp. Just copy that and we'll call this created at, and I have to bring in timestamp here. So we'll always have a created app timestamp, so we'll know when the expense was created, and then we can order by in descending order. So I'll have to bring in the descending function expenses dot created at. So we see the newest ones first and the oldest ones last in the list. But because I've updated that schema, I now need to run the migrations. So the first thing I do is DrizzleKit generate PG to generate the new migration. So I get that new migration file. It's going to be the alter table to add the timestamp default now. And then I can bun migrate.ts, and that migration is complete. And if I check Drizzle Studio, we should see that new column in here with a default timestamp added. Perfect. Okay. I'm going to select, change that just a little bit to have a limit and an ordered by. For post, I don't think I need to change anything here. We're just inserting the expense value and the user ID that we're grabbing from the cookie, which is coming from the middleware. Total amount spent. This is going to be different now. So we're going to const total equals db.select from expenses table, where the expenses table user ID is equal to the currently logged in user's ID, and I need var user equals c.var.user. Gee, no, not var, const. And we're not just selecting all the expenses. What we're going to do is select the sum of all the amounts for that user. And this is actually going to be an object. So I'm going to say that the total, this is the thing that we're selecting. So select the sum as total from the expenses table where the user ID is equal to the currently logged in user ID. And the sum function needs to be imported from Drizzle ORM. So I'll import that. And this should be good. I need to await it. Let's see the type we're getting back. So this is an object. Actually, it's an array of objects that contains a total that is going to be the string. So that's kind of annoying. Even though we're only going to get back one value, these select statements always return an array. So in a case like this, I'll just append on a then and have that return the first item out of the array. I know it's only going to be one item, so we'll just force that there. Now this object has a key total and a value that is going to be the total amount. So I'm actually going to call this result and then just return this result, since it's going to be an object where the key is total and the value is the sum. Then for getting a single item, it's going to be really similar to getting all the items here. So I'm going to copy this from up there. So the ID is coming in from the URL. Then we're going to select from expenses where the user ID is equal to the currently logged in user, and where the expense table.id is equal to the ID that was passed in. So we have two equality checks here. So we can just wrap this in an AND function, which we're going to also need to import from Drizzle. So I'll import that, and then it's complaining because I didn't make this async. That's fine. So we're going to grab the single expense from the database where those two things are equal. I don't need a limit 100. It's definitely only going to return me one result if I'm checking for an ID equality check on the primary key. So I am then going to make sure that this just gives me the first item out of the array, the only item out of the array, and then I can delete this part here. And then if there was nothing in the array, we're going to return not found. Otherwise, we'll return that expense. This is going to be similar for the next one too, where I can paste that in, make sure this is an async function, and instead of finding a single item here, we're going to delete the single item from the expenses table. So everything else, I guess I don't need the order by. I didn't need the order by up here too if we're just getting that single item. So we're deleting where those two things are equal, and then because this is a delete, it's not going to return anything by default, so we just have to append the returning thing in here. So delete the item, return what you deleted, make sure you only get the first item out because it's always going to return an array. Then if there was nothing to delete, then there will be no expense returned to us. So we'll return not found still. But if we were able to delete that, then we can just send back the deleted expense to the client in case that's useful. I don't know. But all of these now have the SQL statements that we would need to access the database correctly. So this should all now work. If I go back to the front end application, I haven't implemented anything in the front end to be able to delete expenses, but I can see the expenses there. I can create another one here. Let's set this to just be some random numbers. Submit that. I still have that wait in the front end that I should have deleted by now. When we create an expense, I have that fake wait 3 seconds before you do anything so we can see the loading state. So I've deleted that now. So created the expense. We can see them in descending order. If I go home, yeah, I can see the total amount. So this all seems to be working pretty well. It really didn't take much to get those pieces there. So now I want to deploy this again to Fly.io. I want to make sure that everything's working in production and local. So I'm going to take that URL again from the environment variables. And the first thing I'm going to do is send it straight over to Fly.io. So fly secrets set the database URL. And then I'm just going to fly deploy to deploy this app. And this should just work on my servers because the Kinde Auth service is already in the cloud, because Neon database is already a database service in the cloud. When we go to host the application, everything should just work as long as we have the environment variables set up correctly. Okay, so that's deployed. Let's check out the URL and see if we have a full stack web app actually deployed. So there we go. I'm still logged in as myself. I can see my expenses. I can see the total amount. I can create a new one. Let's just do $1 here. I can see that in the list. That's perfect. So this is now a full stack deployed React app with a database, with Auth, and this is a pretty decent foundation to start building off. There are a lot of things that you can add to this, or you can use this example to then build pretty much any application that you want. Now we're going to add a few more features and clean things up a little bit, the UI and the code. And the first thing we're going to start with is actually adding form validation here using Tanstack Form, so that if we were to try and create an expense without a title, for example, or with an incorrect amount, it would actually give us a little bit of warning. So if we go to the Tanstack Form docs, there's a section on form validation, and there's a few different ways of actually validating the form input, but we are gonna use Zod since we're using that in the front end and the back end. And I will show you how we can share code between the back end and the front end so that we can share these Zod objects. But we'll start pretty basic first. So the first thing we're going to want is the Tanstack Zod Form adapter. So we'll need to install that into the front end. Bun add that. And then we're going to use the Zod Validator when we set up the form. So I'll just copy this line, find the part where we're using use form right here, and say that we're going to default to using the Zod Validator. We need to bring that into. So import Zod Validator, Tanstack Zod Form Validator. And then this is an example of one of the validators. So I'm going to copy that for the field and paste that in here. So let's just start with the title. I'm going to add the validator right here, and we're going to need to bring in Zod for this. I'll also just import Zod. And now basically this validator is going to work by checking for every time there's a change in this field, we can specify some sort of requirement with Zod. So I'm going to say that this has to be a string, maybe with a minimum length of 3. We can just keep it simple like that for now. And if we go back to the app, we should be able to see this. So right now there's nothing in there. If I try and submit this, I'll now get this error message coming from Zod. And as I start typing in, it will go away when I hit those requirements. And then if I start deleting these characters, it gives me that message again. And we can customize this message a little bit. So if we go back in here where we say it's min 3 characters, we can put in a message saying something like title must be at least 3 characters. So we'll just leave it like that. And now when I start modifying it, yeah, it says the title must be at least 3 characters. And since this doesn't pass the validation, I can't actually hit the submit button. So this is pretty nice. That's a simple version of this. But since we're already using Zod in the backend and we already have some Zod validation, so if we go to the backend routes, to the expenses route, when we make a post request to create a new expense right here, we are using the backend Hono Zod Validator with this create post schema that I've set up right here, which is validating against this stuff on the backend. So since the thing being input into the form form is being submitted to the backend and the backend is doing this validation before we'll even accept the input, it would make sense to use this Zod object in the front end of the application as well. So what I'm going to do is take this Zod code right here, because this is going to be shared code. I don't want to share all of this HTTP code with the front end. I just want to share this Zod code. So I'm going to take this and put it into a separate file. So I'll cut it out of here, and just in the back end of my application, I'm going to make a shared types file maybe, and I can paste that in here, and then I'm going to need to bring in Zod from expenses. I don't need this in here anymore, so I'll just cut that out, put it in shared types, and I might rename this file or refactor this out a little bit later, but for now, for this simple app with a single type, this kind of makes sense just putting it in a shared types file. But you could always name this file something different or structure this really however you want, just as long as the shared code goes in a separate file. Now I'm gonna export that schema, and I could export this schema too. I don't need this type expense. And in my expenses route on the back end, I can import this, create post schema from shared types, and then this should still be fine, yeah, because it's just using that. And then we're going to do the same thing on the front end now. So if I go back to the create expense form on the front end, from my back end, I'm going to import the same thing, create post schema from the server shared types file. And as I'm writing this, I don't love the name I've given this. So I actually want to rename this to create expense schema. I think that makes way more sense. So I'll update that in shared types and in my backend route too. I just think that name makes more sense, especially as we're using this code more places. So I'm going to take this now, and I don't need to specify my own Zod schema on the front end because I'm just going to be reusing the stuff from the backend. In this validator field, instead of creating a Z string here and having to define what I actually want, I'll just say that we're going to use the create expense schema .shape.title. So this will be effectively the same thing. So if we go back to the expense schema, I can see that the title has a minimum of 3 and I've given it a max of 100. We can put in some messages here too. So title must be at least 3 characters, and I'll do the same for max 2. So I have this schema set up just in one single place. It's shared in the backend route and in the front end route, and I don't need to use Zod directly anymore. And I'm going to do the same for the amount as well. So if I come down here for the amount, we are going to use the amount property from that schema, which isn't really going to do much right now because we're just saying that it's a string, but we could add some regex here, and I'm just relying on Copilot to do this for me. But this is going to specify that the input must be a number. It can't just be a random string, which is going to be difficult anyway, since this input form only allows numbers anyway. But if someone opened up DevTools or something, at least the schema wouldn't allow this to be submitted directly. But it is also gonna avoid having negative numbers, which is maybe something that I want, and I do want in this case. I don't want expenses that are negative in this application. And right now the message just says invalid. So let's give that a better message here. We'll say amount must be positive. And now in the front end, let's see. Yeah, okay, so now I get that message too. So that's kind of nice. And again, this is being shared front end and back end. So we're validating that before they submit the form and after they submit the form and make the request to the server. And I can actually go one step further with this, since when I'm posting this in, this is tightly coupled to the schema that I have, the table that I have set up with Drizzle. And if we check out the Drizzle docs, they should have a section on Drizzle Zod. Yeah, so we'll need to install Drizzle Zod, and then we can actually create Zod objects from the schema that we've defined in our schema TypeScript files. So this can be handy because then if we add new properties to our table, they're just going to automatically appear in that schema validation object. So let's just take a look at how this will work. First, in the back end of the application, we're going to bun add Drizzle Zod, and then I'm going to take some of this code from the example here. So we're going to take the create insert and create select schema, paste that in here, and then I'm going to copy this code and then tweak it as I need. So this is for a user table. Of course, we're using expenses instead. So I'll modify these things. And this can be kind of handy because the insert expenses schema will have all the properties that we need to insert a new object. So user ID, title, amount, they all have to be values. They're all going to be string values. But the ID, since that's going to be populated, is actually an optional Zod value here, and created at, because it has a default value, is also going to be an optional. So that's kind of nice. Then when we select the schema, those aren't going to be optional because they're definitely going to be coming from the database since they're not null. So we can use these anywhere in the application, especially in the back end, to verify we have the correct data before we even try inserting into the database. So I'm going to export these so they can be used. In my expenses route, I could bring this straight in from the schema. Actually, I'm importing the table here. So I could bring in the insert expense schema, the Zod object, and right here in my post, instead of immediately trying to insert that data into the database, the expense object has already been validated there, but the actual insert object is going to have the user ID place as well. So I could create a new validated expense object and just make sure that that is valid. So these things, the expense that is coming from the client application mixed with the user ID, just make sure that that passes the validation test, and then pass that into the database if it does. And if it doesn't, this will throw an error that I can handle in a custom way here, or I can just let the Hono error handling take place. But really, it's a nice place where I can control if this is valid for the database or not before I actually try submitting it to the database. But then this create expense schema, the data that is coming from the client, is really just a variation of this right here. I don't want them to submit the user ID from the client. The ID and the created at when I'm inserting also shouldn't be provided, but everything else is really just a variation on what is being passed in here. And no matter how it's being inserted, I do want those extra validation checks to make sure that the title has a minimum length and the amount is actually a string. So I'm going to take these, I'm going to come in here, and as we're creating the schema, we can customize some of the options here. So I'm going to override the title and the amount fields just to have my custom Zod logic in there, and I'm going to need to bring in Zod for that. So now it's still the same. It has those values, ID, user ID, title, whatever. But now these ones have a little bit of custom logic to make sure a number is put in for the amount, and the title has a min and a max length here. And actually, I don't really want the max length, otherwise I would have used varchar anyway. So I'll take that out. That is good. So that'll always be used now. But what I want to do is take this and put it into the shed types as well. So I'm going to import that from the schema file. And then my insert schema, again, is just going to be based on the stuff that I have to insert into the database. So instead of creating a brand new object, I want this to be the insert schema, but I'm going to omit the user ID and the created at, because I do not want, when someone is posting a new expense, it's actually going to be my create expense schema. When someone is posting that from the client, I don't want them to specify those two things. So this is what's going to go in the form. This is what's going to go in the post request, and it's based on what we're actually having in the database, but with those few variations. And then if I had another thing that I added into this, like I want to add a date so that people can specify which date the expense was based on, that will automatically propagate to all the other parts of my application to make sure that that is valid and verified before I actually try submitting to the database. So that's pretty nice, and I'm using that in the form too, so everything should still be working the same way. If I try inputting a title that is too short, and if I try inserting a number that isn't correct, this should work with decimals too. Oh, it's actually doing, yeah, more, because I'm only supposed to be able to go up to 2 decimals there, but this should work otherwise. Okay, so I should probably change the error message in my schema. So I don't know, amount must be a valid monetary value. Just go with that as the error message. And one thing you might have noticed too is that the styling isn't great here because it's pushing into the next thing. And if this has an error, it pushes the button out of the way if I put a negative sign there. So I'm going to update the form a little bit, make the styling a little better. So in the create expense form, let's change this a little bit. So I'm going to use flexbox, flex col, and then I'm going to wrap each of the elements. So it's a label and an input. I'm going to wrap these each in a div just so they don't interact with each other. So the label from this one or the error message from this one doesn't interact with the label from this one. So wrap both of these in divs. And I might also add a little bit of a gap Y, maybe 4 here. Okay, so everything's spaced out a little bit more. They are completely separate from each other. The submit button went the full length. I don't hate that. I'm going to leave that as is. And then just to make sure everything's working, working. Let's try submitting an expense here. And yeah, everything still works the same way, but now we do have that little bit of validation there. That isn't just a UI validation in the front end, it is on the back end, it is before we get into the database. So we are covering all of our bases using that Zod validation. And while we're on this form, I do want to add a way for the user to be able to specify the date that they spent the expense on. So it shouldn't always just be this day I spent this amount of money. I should be able to say, a week ago, a month ago, whatever, just specify from a little date picker. So if we go into the shadcn components, there should be somewhere a couple of date or calendar things. So this is a date picker where if I click it, the calendar pops over. I just want a calendar there all the time. So I'm going to find there it is, calendar component. So we'll have one of these so a user can actually specify which date a expense was actually made. So for this, we're going to add the calendar component to the front end. Just add that in there. And then we'll copy the code to get the calendar into the application. So we'll need to import the calendar and then just add it in like this. So I'll, in the create expenses page, import the calendar in with the other components. And then this is just going to be another form field. We'll have a couple of things to do here, but we'll just start by duplicating one of the form fields over. And instead of having a label and an input, we'll just put the calendar component. And we don't have state set up for that. That's fine for now, because we're going to need this to work from front end to back end. So we're going to need to update the database table and everything. So I'll just start coding things out right now. So the name is probably going to be date. On the schema, we'll have a date property. And then the selected and on select, we're basically going to copy these things. So the value is going to be the selected there. And on select, this is going to be the same as the on change for the other one. So on selecting a date, we're just going to update the form value. So a lot of red happening here, but we are going to get this calendar component in. I'm pretty sure. Oh no. Okay. So the calendar component is showing up. It's not going to work. Let's just style that a little differently. I'm going to have this self-center itself in Flexbox. Okay, so there's the calendar for the date we're going to select, title amount. Okay, so that all looks nice, but this isn't going to work, obviously, because I haven't set any of this other stuff up. So I have the calendar. I know what I want to happen in the front end, but now we're going to work from the back end forward to get this working. So the first thing we're going to need to do is actually add a date to this table, because we don't have that in the schema. So we're going to need to do that, create a migration, actually push that to the database. So I will add a date here, which is going to be of type date. I'm going to need to import that from Drizzle, and then I'm just going to call that date and make it not null. So that should be fairly basic. And like with most things, this is going to end up being a string. When we pass it to the server as a property of the JSON object, it's going to be a string. When we put it into the database, it's going to be a string. But in JavaScript, in the front end, at times we are going to deal with it as a date. So there is going to be conversion back and forth there, but we'll figure that out as we go. So because I've added it in there and I'm sharing those types, that should have propagated everywhere. So now it's expecting a date when I post it to the API. My form is also going to expect a date before I can actually post to the server. So now I'm going to add, yeah, see, it's complaining there because it doesn't have a date type. So that's really nice. Everything is working correctly. For the default values, I'm going to add a date property right there. And this isn't going to be a new date object. It has to be a string. So instead of just specifying an empty string here, we are just going to convert this to ISO string. And if we take a look at this in a JavaScript terminal, we can see that just converts a date to a string that looks a little bit like this. And the only bit we really care about is this date right here, because this is what the database is expecting, a date in this format. So as long as we keep it as an ISO string, this will be good. So now if we go back into the code, when we have the calendar set up, we're setting its value to be a string value, but this calendar component is expecting a date. So we can just create a new date on the fly for this based on that string, and it will be able to use that correctly. And then when we're setting the date, we need to do the same thing as before, convert from a date to a string. So we'll just convert this to ISO string. And I think I got this a little bit wrong. This isn't going to give us an event object. This calendar component is actually just going to give us the date object. So it's not e.target.value, it's just date. That's kind of nice. Date might be a date object or undefined if we select nothing in the calendar. So we'll do date if one is selected And if it's undefined or null, then we'll just create a new date object, which is the current date. So that's a fine default. So now on selected, we take the date that was selected. If one wasn't selected, we'll just say it's today and we'll convert that to the string. And now I think this mostly, yeah, this should be working. There aren't any errors in there. So we just added that new date field. The Zod validation object is expecting that. So this would be complaining if we got any of that wrong. We have these default values. So that should be it. Everything should be valid. The only thing that won't work, this will fail, because I haven't migrated the database. So Neon doesn't know that we want to specify a date for these expenses. So we are going to need to run a migration here. So if I go back into the backend, we're going to need to run Drizzle kit generate the migrations, which has given us a new migration file. Let's just double check that. So we're just adding the date column there. That's perfect. And then we will try and bun migrate.ts, which will fail because we have current values in the database that contain null values, but I'm saying that the date is a non-null column. So we could make this value nullable or figure out a way of inserting some default dates for the values that already exist. But since I'm still in development, I find the easiest thing to do is just to delete all of that test data that I have in there and start over, since no one is actually using this app anyway. So I'm going to open up Drizzle Kit Studio, which also doesn't want to work because date does not exist. It's actually kind of funny because it's using the existing schema, so I should have done that before adding date. But there is this new SQL Runner tab, so let's try that. Let's say delete from expenses and see if it will just run that and delete everything. Not sure if that works. Let's try select star from expenses. Okay, so it's saying there's no rows. Maybe that worked. Let's try again. So I'm going to try the migrate file. And it looks like the migrations are complete. Okay, so I managed to drop all of the rows using the SQL runner in Drizzle Studio. And now the migration should be complete. So if I check out the expenses table, so I'm going to restart Drizzle Studio. I just want to see that this is working. So it looks like, yeah, there's a date, a created at, amount, title, user ID. So this looks like it's working. I should have no expenses in my database anymore. So if I close that and go back to the application, if I navigate around now, I don't have anything that I've spent and my expenses is completely empty. Okay, so that makes sense. So now if I create a new one, my first expense, and I set this amount to something, I should be able to specify a date now. So let's just say it was the 1st of March, submit that. And now my expense appears here. There's no date, obviously, because I didn't show that in the UI yet. But if we check the network tab, so I'm going to refresh this page, we're going to grab the expenses. We should see in the response that just automatically it creates that date, or it has that date property on it. So we could now show this in the table when we're showing all expenses. So let's actually do that. Let's go to the expenses route, and we will, in the table, we'll add a new table head. So we'll say this is the date. We'll add another skeleton for when it's loading for that. And then when they are all loaded, we will show the date. And this is actually going to show the entire ISO date, which we don't really want. We don't care about any of these zeros because it is just a date. It's not a full timestamp. So what we can do here is we can just split on the T and only show everything before that. That's the simplest way. Of course, you could also bring in a date library and do other things if you wanted, but this will be sufficient for what we need now because then it will just show the date that it was created. Perfect. And just to double check that this is working, I'm going to go random date in 2023. I just want to see that, yeah. So that all seems to be working, and I could even order by the date if I wanted to, but I'll leave that as is. That all seems to be working pretty well. And this is looking pretty okay. I'm happy with this, very minimal. The profile page doesn't look great. The homepage kind of looks okay. The nav bar could do with a little touch up. So I think I'm just going to spend a few minutes just updating the styles a little bit before we move on to the next feature. So in the root file, I'm going to update the nav bar a little bit because I am going to put a title in here too and throw the navigation links over to the right. So I'm going to wrap all of that in a div, make this flex and justify between. Also going to move the P2 to the outer one here. And now this should allow me to put a header here that has expense tracker or something like that. And then these links will all be shoved to the other side. So that's almost what I want, but I do want the max width on the whole thing. So we'll say the max width and the margin auto also goes on the outer div here. And now it looks like that. So that I think is just a little bit better. And maybe I'll center the items as well. Actually, no, I'm going to baseline the items. Let's see. Okay, yeah, so now they all have the baseline there. I think that's good. And maybe I should, instead of having the home link, I'm going to make that be the title up here, which I think is more of an expected behavior anyway. We don't have a home link. You just click the title, it takes you home, right? Okay, so we have all of these. I can go to profile here, and then if I click that, it takes me back to the home page. Okay, so that's a little bit better. The about page, I don't really know what's going to go on here, so maybe I'll just change the about to have, I don't know, coming soon or something. It's pretty lazy, but whatever. Then in the profile page, again, I'm not really sure what I want to put in the profile page. So let's check out the shadcn components, because there's an avatar that we can use, which might be a nice addition. So let's bring that into the front end, and then we'll copy and paste the code for this and dump that into the profile page. So this is really the code I want, the avatar code. I don't think we need hello from profile, so I'm going to put the avatar in there, and I think there's a chance that the user has a picture, which is going to be a string we can pass in here. So maybe I'll do a check for the picture. If a picture exists, then we'll show the avatar image. And I guess we could alt this to data.user.givenname, and then we'll fall back maybe just on the given name. Let's see how that goes, because I don't have a photo, so I think this will just fall back to my name. I'm going to see if Copilot gives me anything here, and then maybe this can just be the given name and the family name. Let's see what this is starting to look like. Okay, so there's an avatar with my name. Maybe I should actually flex this and center them. Yeah, that seems okay. Just for this section, yeah, it'll appear like that. I think that's okay. And then the logout button, I think, should actually be a button. So I'm going to bring in the button component at components UI button, and I'm going to wrap this in a button. And I'm going to check the docs again, because I can't remember exactly how you make a button into a link, but I think that's a supported thing. Yeah, right here. So we'll just do button as child. So it will actually just be an href tag, but it will appear as a button. I think that needs a little bit of spacing. So let's give this MY4. Okay, that's still not amazing, but it's fine. I think it's a little better than it was. So we have the profile page with the logout button, create, expenses, about, the homepage with the total spent. And I think I'm just going to do the same thing that I did for the profile screen with the login screen, just to make that a little bit more consistent. So here's that login screen. I actually wonder if Copilot will do anything for me here. So I think let's put that in a p tag, login or register. We'll do the same thing as before. So I'm going to put in a button that is from at components UI button as child. So that's a button for login, one more button for register. They want to register a new account, and that looks terrible. Let's flex col gap y2 items center. Yeah, okay, that's better than it was. Okay, so now we can log in or register, and everything should still work the same, just with a little bit of an updated UI. Okay. So now we're going to do a little bit more advanced stuff. We're going to work with the caching from React Query, and we're going to add in a feature that is kind of simple to do in a client-side rendered single-page application like this, but I found incredibly difficult to do in anything that uses server-side rendering, like a next.js application. So right now, if you notice, as we navigate around, so I'll go to create and expenses, and I'll just keep navigating back and forth here, every single time by default, default, it's going to re-request the expenses, even though they already appear here, because it's not sure if there are updates to these or not. So we can modify this a little bit so that it only updates every once in a while, like every 5 minutes or so, but we can also add in the newly created expense when we create it, so that if we go to this page, we load in all the expenses, we create a new expense, we can just push that new one into the list here without having to make a request to the database again. This is making the exact same GET request to get every single expense every single time. So we can make that a little bit more efficient. So to do that, I'm going to start by going, I'm going to close actually all of these. And we're going to go to the expenses page where we're making the request to the API right here. So this is the function that makes the request. Here's the use query hook. And the first thing I'm going to do is set a stale time here. So this, I think, defaults to 5 minutes, and it means that as we navigate around, this won't retry and get the expenses for 5 minutes from the first request. So if we look at this in the browser, I'm going to refresh and clear the current cache. So it made that request to get all the expenses, and as I navigate around, it's not going to remake that request. Now, a downside of this is that if I go to create a new expense, then it won't appear on the other page, because the only way that page knew about the expenses is that it remade that request. So we should have an 11th expense here, but it didn't re-request. It made that post request to create, but didn't then try to get the new expense. So if I refresh the page, we then get the 11th one. So I'm not making unnecessary requests, but I'm also not making the necessary one I need to get this new expense in here. But when we create the expense, after it's finished being created here, this response object, this contains the new expense that was created, because we're having the server route return the new expense in the post request. Right here, it gets the result from the database and actually returns that back down to the client. So we're going to have the create expense page update the get all expenses query with the new one when it's created. But before we do that, we're going to refactor just a little bit, because it's going to be easier if all this logic isn't just inside each page and each component. So I'm going to take this function out, the get all expenses function, and I'm going to put that in my API file, just at the bottom here. So we're going to export async function get all expenses. And then this get all expenses now exists in the API file. So I could just import this function into my expenses page. But instead, I'm going to go one step further. I'm going to take all of this data out of here, and I'm going to come back in and I'm going to do the same thing that we did with the user query options. So I'm going to export const get all expenses query options, create a new query options object that contains all of that data from before. So this is the unique tag. This is the function. It's just going to grab all the expenses, and here's that stale time from before. So this now just exists in the API file, and all I need to do is import this back into my expenses page here, and then I can pass that straight into the use query. So everything is still going to be the same right now. We haven't made any updates to how it's actually making the request or getting the new data, but this is in a new file now, which will make the next step a little bit easier. So if we go to the create expense page, this is going to modify the expense. It's going to create a new one in the database, and then we just want to update the data on this page. And the way that React query works is that it is basically an async state manager. So it can handle the request states for us. It handles the error state and the loading state and all of that. But really, it's just a state manager. It's holding the expenses in memory somewhere for us. It's managing that state. So all we're going to do is update the state for this query option here. And then this page will update with any new state that we have. So in my create expenses page, I'm going to need to access that query options object. So I'm going to import that from the API, import it up here. The get all expenses query options. I'm also gonna need use query client from Tanstack Router query. And then at the top of the page component here, we're gonna create a reference to the query client using use query client. And then using this object, we can update any of the state that React query is keeping track of. So we make the post request to create a new expense. If there's an error, we throw the error. Otherwise, we should be able to get the newly created expense from the response object. So we should be able to await res.json, and this should be the new expense object. New expense is the object that has all of these properties on it. It's actually giving us an array. So if we go back to the expense expenses route here where we make the post request, we can see this is where we're submitting it to the database. We're telling it to return whatever it puts into the database, but it's always going to return an array to us in case we input many values, or when we're selecting, we might select many values. So since we know that this is only set up to post a single expense, we can have the database just return a single item by attaching a then and getting the first item out of the array. So now in the create expenses page, what we're getting back from the API when we create a new expense is the newly created expense object. And now all we need to do is put that into the array of expenses that the other page has. So we can use the query client here, and we're gonna say query client set query data for the get all expenses query options using the query key, and we get access to the old data, and then we can basically return the new expense in the old data. But this will only really work if someone has already gone to the all expenses page, then gone to create. If someone were to just navigate straight to this page, expenses wouldn't already exist. So we're going to do one extra step here, that is to get the existing expenses from the query client using query client.ensure query data from the get all expenses query options object. So this line right here, if they have already been loaded, if someone's already gone to the all expenses page, we just immediately get what's already in the cache. But if they hadn't already gone to that page, if they'd started on the create page, this will go to the server, it will get all of the expenses, and then we can modify that by putting the new expense into that locally. So now this is gonna look like this, where we're gonna return an object here. And the thing that the server actually returns to us is this object that contains a key expenses that then has the array of objects in there. So it's not just adding it to an array, we are manipulating a whole object here. So this is going to need to be an object that contains basically anything that exists in the existing expenses, but we're going to manipulate the expenses array by putting in all the existing expenses with the new expense at the end of it. So grab all of the existing expenses, hopefully locally if that's already been done, or go to the server and get them if it hasn't. Then update that local cache to include the new expense that was just created from making the post request. And then once all of that is done, we're going to navigate over to the expenses page. So let's take a look at how this works. If we go to the expenses, I'm going to clear all of this and I'm going to refresh the page. So we go to this page and immediately it makes the request to get all the expenses from the server. So that's one request to the server to get all the current expenses. Then we go to the create page. I'm going to create a new expense and then submit this. It's going to make the post request, and that should be the only request made. So it made that post request. If we look at the headers, it's a post request. The response is the one that was just created, and this has ID 12, and then we just input that into the current expenses that exist, and I put it at the end, which was a mistake because the way this is ordered, this should have actually been put at the beginning. So I just need to go back here and switch that around. But we're just updating this internal context, really, that React Query is managing for us. So it's really just an async context manager for us that works really well with making API requests. But we can use it to manage state for the entire application. And then just to verify this works, I could go to the create page, and again, I'll refresh everything. So this is the first time coming here. If I make an expense and then I submit this one, it should make the post request, but then it should also make a get request since we haven't already got the expenses. And we actually get the expense in here twice. This is interesting because we waited. Let's look at the code here. We create a new expense here, then we get the existing expenses. And if this one's already been created, then this will actually get the already created expense. So that's kind of interesting. A simple way of solving this that keeps everything working correctly is that we'll make sure that we have all the existing expenses before we post the new expense, and then we'll put the new expense into that list. So now if I go to the create page, refresh again, so we have nothing, we have no data yet. I'll just make another expense, submit that. And this time the order works correctly, so we actually get the list of expenses. And this means that there's just less network requests, and it also allows us to do more customizations locally, which is something I love about client-side rendered applications. So what we're going to do now is kind of an optimistic update, where instead of staying on this page until the expense has been completely created, what I want to do, this could take a while. You could have like images for receipts or something, or just a really slow network request. So instead of just hanging about here, I want to immediately navigate over to the expenses page and see the new expense appear in this list but in a way that shows that it's still loading, it's still being created, and if there's an error, we can show some sign of an error, or if it's successful, it will just appear in a successful state. So this one's a little bit more complex, but not too difficult. And I'll try and do this step by step. So the first thing is I'm going to move the navigate right here, right before we make the post request. So we'll end up on the expenses page. And at the same time, I'm going to move this code out and put it in the API file to kind of keep that consistent and easier to manipulate. So in here, I'll make a new export async function, create expense, and I missed the new expense code, so I'm going to put that in here too. So if that's all good, we can just return the new expense. So this function is just responsible for making that post request. We're going to need a value in here, and this value is going to be whatever we send to the server. So if we go back over to the shared types file, this is what the server's expecting. We can just export a TypeScript type here, which is going to be z.infer type of that. And then I'm going to need to import Zod into this. So this is the TypeScript type that represents what we need to submit to the server. I'm realizing now we don't actually ever want the user to submit an ID, so we'll omit the ID as well. That should have been done before, not a huge deal, I'll just add that in now. But this means that we can now bring this type in here. So I'm going to import type create expense from server/shared types. So this function is going to be expecting the new value, which is a create expense type. So all of that still works. And then I'll import that into my create expenses file. So from API, we'll import this. So I'm not handling the API directly. I'm just calling functions that exist in that API file. And that's going to look like that. So I can just call that function to create the new expense and get the new expense object. Now I'm going to add a fake timeout here. So we'll add 3 seconds. We'll pretend that this is a really slow network request, and this is going to take 3 seconds to even go to the server. And now we'll kind of see what's going to happen here. So if we create an expense, we'll navigate immediately to the expenses page. And then in the background, we're going to try and create that new expense, which might take a little bit of time. Then once that has been created, we update that internal state. So currently this will look a tiny bit janky, but you'll get a sense of what I want to go for here. So if we go to the create page, just create a new expense, hit submit, we'll immediately be navigated over to the expenses page where we get to see all the expenses. Then when the new one's created in 3 seconds, it just appears there. So that's the kind of behavior, the kind of custom behavior that I want that you can implement in a client-side rendered single page application. But what I would really love is that we can navigate over to the new page immediately, but see some sort of loading state here to indicate that it's currently loading. And then when it's successful, we see it here. And if there's an error, we'll show an error state. So there's a lot of customizations like this that we can do. To achieve this though, we're going to need to store the state of the new expense with React query somehow. So right after we navigate, we're going to indicate some sort of loading state. And then when the new expense has been created, we'll have that success state. And we could even throw this into a try catch and handle some error state as well here. But this is all going to be handled on the other page. So the way we're going to do this is with React Query just as a state manager. So right here, I'm going to say query client set query data. We'll give it a key. So I'm just going to call this loading create expense. And the data I want to send it is going to be the data that is being submitted into the form. So that's going to include the title, the amount, and the date. So I'll just call this expense singular. So I'm going to send this data over to the other page or to any page that wants it so that it can present that in some sort of loading state. And then since this is my loading state here, once we're done, I'm actually just going to put this in a finally block. So whether this was successful or unsuccessful, I am going to just set this to be an empty object. So again, this just represents the current loading thing. So if we are currently submitting, it's going to have that state. And if we are finished submitting, whether it was successful or not, we're just going to remove that because the loading state no longer exists there. This whole bit of code here is actually part of the success state. So only on success do we update the array that people see on the page, and then we'll handle the error somehow in a little bit. So now using this key, I can go to another page. So I'm going to go to the expenses page, and I am going to use query again. So I'm going to say const data equals use query, and this time it's going to be for this key, which I'm going to have to put in an object query key, and this data is going to be the loading create expense object. So this will be whatever data was passed in from the other page. And before I do anything crazy, I think I'm just gonna dump this out to the screen. So we can say JSON stringify this object, just so we can see it on the page for now, and then we'll make it look a little bit nicer. So just to go through that again, when we create, we will set this value just on some global context. You'll get the value that was in the form while it's loading, and as soon as it's done loading, we'll remove that value from the context. Then on this page, we're just going to grab that value and show it if it exists. So we'll have some sort of loading indicator here. So if we go and create a new thing, I'm going to input some data, give it a value, submit that. And then on this page, we have that data that is currently being submitted. Then when it's done, we just see that new expense appear here. So really what I want to do is get that data into the form here, or rather the table. Right now, this doesn't have a type. It has an unknown type because useQuery has no idea what's coming from here. So to fix that, I'm going to take this out again, this key, and I'm going to create an object in my API file just to keep all of this code in the same place. So export const loading create expense query option. So we're going to create a query option object here, where the query key is going to be that string that I was using before. The query function can return an object, stale time can be infinity, and then we can just add a type to this. So this is going to have the type, it's going to be an object that contains an expense property that is either going to be undefined or that create expense type that we are getting from the shared types, because that's what is being input into the form. It's that data of a date, title, and amount. And I don't want to make this undefined. I want to make it optional, which is undefined. So now with that there, it knows what type is going to come from this query option. So in my create expense, I'll use that instead. This is for the query key of this option. I should import that from my API file, and I should probably refactor that into a different file at some point. And then right here, I'm going to make sure I do the same thing, keeping it all consistent. That's this one up here. So I put that in there. So again, we're just setting that value, then resetting the value. Then over here in expenses, I'm going to use that loading create expenses query option. We can bring that in from the API file. And now this should know that the loading create expense is actually an expense object, or it's undefined. So this is good. I'll remove this now. And what I want to do is have my own table row that appears in the table if we're loading this data. So I think I'll put this at the very top, and I'll just say that if the expense is being created, if there is an expense loading, we'll add a table cell there that doesn't need a key because it's just a single expense. It doesn't have an ID anyway, so there won't be an ID here. We will have a title, an amount, and a date. And then maybe for the ID, because it doesn't have an ID and I want to demonstrate that this is actually loading, I could just put a skeleton in the ID field. So now if we're loading it, we'll just present a different cell that demonstrates that it's currently loading, and there'll just be a skeleton since it doesn't currently have an ID yet. So I'll go to create a new expense here. If I hit submit, we see the details that we are able to see, and the details that are hidden because they're part of the database won't come until it's done loading. So I'll go to create again. You can see that's the loading state. Maybe I'd want to do something else to reflect that it's loading more. Maybe I can actually skeleton the whole thing and have it pulse in and out. But that is definitely a cool feature that you can implement in something like this. And I really like that because when you create the new expense, you see the loading state on the page where the thing is going to appear. This is where it's going to exist eventually. And then the moment it's actually ready to be presented fully, it exists in its natural place. And this won't work for every single feature, but it is nice to know that you can achieve something like this. But we're not yet handling the error state. So we're going to add another component in here. We're going to scroll down to Sona and bring this in. Basically, this component shows these little things in the corner here so that if there is a success state or an error state, we can use these things, and we'll use them when we start deleting expenses too. So I'm going to grab the code for this. Actually, I guess I need to install it first. So we will add that into the front-end code. Then we should be able to copy the example. Actually, we need to put this this in the root of the application first. So we're going to bring in the toaster component, which we're going to put into the root file because this is the layout of our entire application. So we're going to dump that into the very bottom, not the import, the actual toaster component, and then we'll import the toaster component there. So this just allows any page to see the notification no matter where it's triggered from. So that's all we need in there. And then in other parts of our application, we can trigger that just by calling this toast function. So I'm going to copy this code and the import from the top. And over in my create expense, this is where I'm going to trigger it for now. I am going to import the toast. At the very bottom here, we are going to handle the error and the success state. So on error, we are going to trigger a toast, and I don't think I need any actions here. I'm going to delete that. So we're going to have expense created. This is going to be the successful toast, and we'll just have like an error toast if something went wrong there. So the error can say something like failed to create new expense. And I guess we could have a link that sends them back to the create page if they want. And when it's created, we can say successfully created the new expense and even put in the ID there since we have the expense that has come back from the post request. So now just with this little bit of code, we get a little more UI there. So I'm going to go create an expense, a new one there, submit. We have the loading state. And as soon as it actually comes back from the server, we see that there, but we also see this little toast pop up here. And if we were to trigger an error, so if I go into API, instead of the create being successful, I will throw new error, server error. And now let's try creating that. And we pretend that the server malfunctioned, and we should get a little error pop up here and no new expense up there. So that's all working perfectly. So I'll delete the error. I'll leave the timeout for now just so we can still simulate slow network requests. And actually, I'm going to make this a little bit slower to demonstrate the power of this, because this is especially handy if you're uploading like large files to an S3 bucket or something, which can always take a while no matter how fast your internet is that with this type of application, you can input something here, hit submit, it shows the loading state, but you can navigate around. And then the moment that's actually successful after 5 seconds, we get the little toast there and we can see that this is updated here without having to make unnecessary network requests. We can also go to this page, navigate back and forth. We could create a new expense, but when we get back here, it's still in the loading state and then updates automatically. So all of that just works seamlessly and the user can still navigate the app even if their network request is slow or you are trying to do something like upload a large file or a lot of data or something. So the next thing I want to do is actually be able to delete these expenses, have a little delete button next to each of them, and we'll use a couple of the techniques we just used there as well. So on the expenses page, we're going to have another column here for delete, and each expense is going to have a table cell with a button for deleting. And we're not going to put the word delete in there. Also, make sure, for some reason, my VS Code keeps bringing that in from React Day Picker. Make sure it's coming from @components UI button. But if we go back over to the docs for button, I believe there's some documentation about using it with icons. Let's look. Yeah, all right, there's the icon one. So if we look at the code here, it's bringing in a chevron right icon. Actually, I'm just going to copy this whole thing from Lucid React. So what we're going to do is instead of bringing the chevron icon in, we can look for a trash icon. That's probably going to be good. And then using the provided code, this will hopefully look pretty nice. So again, not chevron right. We can use the trash icon instead, and we should get, yeah, okay, these look pretty good. All right, so each of these have a trash icon next to them, and I'm just going to make sure that the skeleton has an extra cell, and my loading state is also going to have a skeleton cell there, because you don't want to be able to delete an expense if it hasn't even been created in the database yet. So now I have that delete button. On click of this button, we need to trigger a delete for the current expense, and the delete is going to need all of those things that happen in a network request. We're going to need to know about any error states when deleting, loading states, and if it was actually successful. To keep this nice and clean, we're going to use Tanstack query. Again, we're going to use a mutation to actually do this, But because the mutations apply to a single expense and not to all of them, we should be able to delete a single one at a time. It's going to be a little bit simpler if we put some of this in its own component. And at a minimum, we can just take the button and put that in its own component. And I'm going to keep this in the same file for now, but you can refactor this into a different file if you want. But I'm going to call this expense delete button. And then we are going to return that button out of here. So this is just going to render expense delete button. That's perfect like that. So it still just renders like that. But we're also going to need to pass in the ID of the expense so that it knows which expense to delete. So we'll pass in ID equals expense.id. And then we need to use mutation here. So you can go to the Tanstack query docs and check out everything you need to know about use mutation. But I'm going to scroll down to the side effects section, and I'm going to copy all of this code to put into this component here. We're going to need to import use mutation from Tanstack React query. And then the mutation function itself just needs to be a network request to delete an expense in this case. So I'm going to create that function in my API file again, export async function, delete expense. We're just going to need the ID of the expense here. Then we will await api.expenses.id, and that's just how it appears on the backend API to make sure it's a number dot delete, and then the param that we give it is gonna be the ID, and it's gonna complain because it's expecting ID to be a string over HTTP. It has to be a string, but we're trying to pass it a number, so we can just to string here, and then we'll just do the standard if res is not okay, throw an error. So we now have that delete expense function, which we're passing in here. We just need to make sure we import that in the expenses page. So this use mutation is going to use the delete expense function. I don't need on mutate. I just want to be able to handle an error case and a success case. So I'll delete that one as well. And I don't really need any of this data here either, because if there's an error deleting, then I'm just going to do what we did before and show a toast that says error description failed to delete expense. And then on success, let's do the same thing. Toast expense deleted, successfully deleted expense. Okay, perfect. So these are the things that I want to notify the user on error and on success. I'm going to make sure that toast was imported correctly. Yes, it was. Okay. So now I just need to trigger this mutation. So we'll say const mutation equals, and then when the button is clicked, so on click, we will give it a function that triggers mutation.mutate. So this is going to invoke the delete expense function, and then we pass in any properties it needs. So this needs the ID of the current expense, and that's pretty much it. There's just one more thing. When the mutation is currently loading, I want to make sure that this button is disabled, and it's actually is pending. So if it's currently in the state of deleting the expense, we make sure we disable the button. I think we'll just display something different. So if it's pending, we can just show 3 dots, and if it's not pending, then we'll show the trash icon. So this should be good. On click, delete the expense. On error, show a toast. On success, show a toast. Don't allow the button to be clicked if it's currently pending, and just show the trash icon if it isn't. And one more thing, just so we can see these loading states, I'm going to add a 3-second delay on the network request. So now if we go back, we should see all of that. That looks good. If I refresh the page, you can see the skeleton appears for just a second there, but that was all the columns. And now if I go to delete, let's delete 21. If I click this, it's in that loading state. I can't click it again. And this should be successful. Expense deleted. That was successfully deleted, 21. But this does still appear there, and I'm allowed to click this button again, which should actually cause an error, because when it goes to the server, it should, yeah, failed to delete expense 21 because it shouldn't even exist. So if I refresh the page, it shouldn't appear there. But the reason it still appears is because it's not changing this state, the state of all the expenses after delete. So that's just one more thing that I need to do down here in my expenses page. So on success, I also just need to remove that expense from the array of expenses. So this is going to be really similar to in the create expense, where we're setting the query data to be the existing expenses plus the new one. We're going to do a variation of this where we actually filter out the old one. So first, I'm going to need the query client. So const query client equals use query client. And I need to import that from React query. So right here. And then at the very bottom in my delete button, I'm going to set that to be, I guess I need the existing expenses. So this one I'm actually going to use the function for because this will give me the existing expenses if I pass it a function instead. Then I'll have this function return the object. Just need an extra bracket there. So we'll return the existing expenses, but we're going to need to filter this. So existing expenses dot filter the expenses. That looks good. I'm going to change this question mark to an exclamation mark because there's no way that this will be presented unless we already have the expenses. So I'm just going to put that in there like that. So we're going to filter if the expense has the ID of the current one that we just deleted. It was just successfully deleted. Then return false. Don't include that in the array. Otherwise, just return true for the other ones and we'll still see them all. So now with the delay, we should see a little loading state and then it should just get removed from the list. So I'll try this with 18. I hit delete. We get the little 3 dashes there, and then it should just get removed with that little successful toast at the bottom. And this should work no matter how many we do it with. So I'm just going to delete the top 4, and these can all be deleted. And as they start getting deleted, we get these little notifications at the bottom. So that's just a nice indicator it was deleted. It gets deleted there. And we could even, so delete these and then just navigate around to different pages as well. And we'll see that they were successfully deleted there. And we go back. It doesn't make a new request to get all expenses. That state was just managed internally by the application. So this does lead to a very customizable user experience that you can make as nice or as not nice as you want, but you do have the control to do whatever you want here. And there's a lot more you can do with this, both feature-wise and tech-wise. Both React Query and Tanstack Router both support using suspense. So instead of using query like this, you could change it to use suspense query and then use suspense and error boundaries in your front end if you want. You can separate out the pages to be lazy loaded pages so that you only download the JavaScript for each page as you need it. You can separate out individual components. So if you have a large component like the date picker for the calendar, you could have that be separated out and download that separately. And while that's downloading, you could use suspense to show a loading state. So there's a lot of things you can do here, a lot more to be discovered, but this is definitely a good foundation to get started with. And if you made it all the way to the end of the video, thank you for watching the entire thing. If you have any questions, feel free to leave a comment and check the description, because if there's any updates or anything else I need to communicate after this video goes out, I'll just leave it in the description area of this video.